Bluewater chapter of the Ontario Building Officials Association Builders Forum event. We run this event annually and around the same time each year in March. This is the second year that we've ran it virtually, and hopefully going forward, it's either back to the in-person format that we've done with potential hybrid opportunity to include a further outreach to the building community. So the intent for today's program is to give back information related to building code and any other relevant matter really that affects the building industry. And that's kind of what we're doing here today. So we have 4 technical sessions lined up. We will be moderating questions through the Q&A function throughout the sessions, as well as by the raise your hand function. So if you do have a question throughout, we've had one of our presenters indicate that they would respond to questions throughout while trying to keep their presentation rolling through. We'll kind of assess that as we run through here today. So again, I'll do a self-introduction. My name is Dieter Weltz. I'm the chapter chair of the Bluewater chapter, and I'm the chief building official, building planning manager for the municipality of Brockton. That's kind of where I would conclude at this point. We do have our first presenter here available. So Gerald, we'll turn it to you at this point. Gerald Moore is with RSM Building Code Consultants and provides building services to municipalities as well as to the private sector. There's education that RSM provides as well. So Gerald, I'll let you do your self-introduction here as well, if for any other information you want to provide us about RSM and the presentation as well on the building code changes.
Okay, everything, can you hear me, Dieter? Can you see my screen?
Yes, we can, Gerald.
Okay, excellent. Just making sure everything's working the way it should. Dieter, thanks for the introduction today. And it's my pleasure to present today at the Builders Forum the changes to the building code. Of course, my name is Gerald Moore with RSM Building Consultants. I've been a building official with for many years with municipalities, and I've started RSM Building Consultants, and we support municipalities through, peaks of permit volume. We come in and we help with plan review and inspections, and we also help with complex and larger buildings. And what we also do is a lot of training. And one of our things, mandates with training, of course, is we like to make sure we keep up with the new code updates. And we like to do a little bit of a traveling road show to let everybody know what the heck's going on with the building code. It used to be that we would get a code every 5 years, and that was the code for 5 years. But then all of a sudden it started changing, where we had a code every 5 years, and then they kept putting amendments in the building code between those 5-year periods. And then all of a sudden they changed it to say, well, why don't we make changes, but we're going to give you the changes 2 years ahead of time, which actually maybe isn't a bad thing for us all. And that's kind of what really happened with this particular information, is that it really was a matter of bringing out changes, which if you look back in your 2000 building code, 2020, the changes for this were all there, but they were not effective until 2022. So let's have a chat about these particular changes with regards to stairs. Give you an idea. I've kind of given you a little bit of introduction of who I am. I've been working in the municipal building inspection field for a few years, and myself and my team at RSM, we do a lot of work with building codes and supporting municipalities. We don't really do much private work, but we do work for a lot of support for municipalities because we do see the need, as we all, if there's builders out there, of course, you see that you still want your building permit in 2 weeks. And so that's what we're here to do, is support. And so doing this, we do a lot of support for builders and designers in training. So what is going on with these changes? Well, of course, back in 2020, before all the craziness with the pandemic, one of the big things we were all worried about in the building industry was all these changes that came in 2020. And back then there was quite a few changes. There was a lot of changes. And so when these changes came into play, they actually released changes also in 2022. but they didn't, well, of course, weren't effective until 2022. Well, we're going to talk about a lot about this. We're going to talk about why and when this is happening. Of course, we're going to talk about the new defined terms and the stair configurations in the interior building code. The stair dimension changes, which is, a small change, but a big deal. Landings, and then we're going to talk about handrails and guards. So why are we doing this? Well, the province basically started a mandate to say, hey, we are getting too far off the National Building Code of Canada. And for all of maybe a few of you that may not know, the Ontario building, the way it works is the Canadian Commission on Codes, they produce every 5 years a National Building Code of Canada. And they basically say to the provinces, you have the option. You can either just adopt our model National Building Code, or you can use this as a model and create your own code. And that's what Ontario has done for many years. It's based on the National Building Code, but there's a lot of flavor from Ontario in it. But throughout the years, it has really gotten off, and they are really becoming more and more different. So there's been this initiative to pull the codes back together again. And that is why we're seeing a lot of these changes today. It's why we saw a lot of the changes in 2020, is because we're trying to wrestle the OBC and pull it back to be more uniform with the National Building Code of Canada. So that is why, if you're in Alberta right now, you have been dealing with these things already. But in Ontario, these are new because we are being sort of pulled back into conformity with the National Building Code. So that's the reason. That's why we're all here and why we're doing it. Now, it's interesting with the transition rules. Normally, like I said before, when we get a brand new code or an official amendment, there's a transition rule in the code in Division C, Part 4 that says, hey, generally it says something to the effect of, these changes are for any permit that has been applied for after January of 2022. And then you have 6 months to start. Other than that, you're going to be following the new changes. But it's interesting when I started really digging into the details with this, because this was done a little bit differently. It really, what the code said is that, this is the code of like when we looked at the changes, it said generally, this is the code in 2022. It really didn't give us much of a transition rule. So I'd talk with your local municipality on how they're dealing with this. If you have an application in prior to 2022 and you have the old stair information in there, are they going to accept it based on the fact that you applied for it prior to? Double check that with them on that because it's a little bit, it could be taken either way based on the way that the ministry changed the update. There really wasn't a transition rule in the code. It just simply says effective January 2022, these are the changes, which typically means it's when the permit is issued. So there's a little bit of a limbo there. So I would say check with your municipality, have some discussions with them. But what I'm finding generally, though, is if you've applied for a permit after January 2022, it's no question. If you applied before, a lot of them are accepting up to 6 months for the old changes. So definitely something to touch base with your local municipality. So let's talk about the new defined terms and configurations. Now, one of the things you're going to find with this first section is that it's not about per se a change. It's about what we're going to call it. So the building code is one of those documents that is very specific on what we call things, defined terms. And all these years, you've called it a certain thing. You're going to have to erase that. And you're going to have to start calling it something different because the code is now, because it's getting more in line with the national, it's taking on the national's terms. And it's also being more, it's clarifying certain things. So I do think that some of these changes are actually good, but it's going to take a little bit of time for you to stop saying certain terms because they're no longer applicable when we're talking about stairs. When it comes to the building code, the term you say is, because it's a legal document, it's very specific. And that's really what's happened a lot in these changes. So previously in the building code, there was no defined term for flight. So when we looked at this particular drawing here, is that one flight of stairs or two flights of stairs? You get people thinking, oh, that's one flight, then some people saying two flights. Well, now it's very clear. The building code now tells us that a flight means a series of steps between landings. So we here have two flights of stairs. Why is that important? It's important because if you're trying to determine the configuration of these two flights of stairs, you can have two different configurations. You've got two different flights to deal with. So now the code, when the code talks about a flight of stairs, you now know how this particular could be separated into two flights. And so two different maybe sets of rules or how you're configuring it. So this was a really good clarification in the building code that really talks about now what is a flight. So it clarifies when we're dealing with these specific flights, not that we have to have uniformity perhaps through this entire stair system here. It has to be to the flight. So that was a good change. And now we have a defined term for this particular flight term. So what are these new terms? Well, we've got the flight is now determined, so it hasn't really changed. It's just given us some clarification. We now have a new defined term. We don't use the word angled tread anymore. It's gone. We used to use that word, so I've got to throw that out. And now we use tapered tread. So now the building code does not use angled term. It now has this term called tapered tread, and it does have a definition. It is a tread with a non-parallel edge that increases or decreases over its run uniformly over its width. So in this case, when you're using a circular type stair, you're going to need to use tapered treads in order to achieve that, which essentially, right, you have a smaller run on the inside that you would have on the outside. And so we no longer would call that an angled tread. We do now call it a tapered tread. One of the things you'll notice here is that it says it has to be a uniform change over its width. So I know we love live edge stairs and they look beautiful, but if you tried to use a live edge stair, you would have a difference of width, but it wouldn't be uniform, right? It's going to be going in and out. In this particular case, the code is clear. It has to decrease uniformly over its width. Tapered tread. The other thing it's done is it's set up different configurations of what stairs shall consist of. Previously, the code talked about this thing called you can have a straight run. Well, now it talks about a straight flight, which really brings it in line again with that defined term of a flight. So if you had like the first diagram, we have two flights. Your first configuration would be a straight flight. And maybe you might have in the second one, you used to call it a curved run, but now we're going to call it a curved flight. And then the one that a lot of designers and maybe builders have all been waiting for is this new stair. Well, it's not really new. We all knew about them. We all loved them. We all wished we had them. But now the building code actually does permit a spiral stair. And so you are permitted to have a spiral stair. We're going to talk about some restrictions later on when we talk about those. But really, no changes here other than the spiral stair is added. But we've changed the term. We don't use straight runs or curved runs. We use straight flights or curved flights when we're talking about our stairs. When we have a stair within a dwelling unit, it talks about a certain type of stair system. And again, it used to say X and now it says Y. Previously, it used to say we could have straight runs with winders. And now it's really just following this new terminology saying rectangular treads with winders. We're going to talk about the rectangular treads a little bit later, but you're allowed to have rectangular treads and then you're allowed to have winders within that stair system. Previously, it talked about using straight runs with curved runs. Well, now it has changed that. It says you can now use a mix of rectangular and tapered treads, but the tapered treads must turn in the same direction. So again, we've all been doing this in the past. We're just changing our terminology on how we talk about a stair when we're really dealing with code compliance. And then, of course, to bring up again, a dwelling unit is permitted now to have a spiral stair, but there are some restrictions on that particular type of stair. So those have had some configuration changes with regards to the names. Previously, we had service and mezzanines and live work unit stairs. And it talked about what it served. Well, now they've been more specific and they've split it up. Now we have service stairs that only serve service rooms or spaces, more industrial likely, part 9 non-res. We also have stairs to unoccupied attic spaces, which contain no storage or living space. There's been no changes to any of these provisions, but they've changed the names. And even on this particular stair to an unoccupied attic space, before it never had a limit on maximum rise and run for the use of ladders or something like that. Technically, though, as soon as you start putting storage or living space up there, you aren't permitted to use this particular type of stair to an unoccupied attic space. So terms, changing the way we talk about the building code. So let's talk a little bit about this new spiral stair. Now, I've just put a few of the requirements here, but what you will also notice on the slides that we have in the presentation today is I have all the code references. So certainly make sure you're taking a look at the particular code references to kind of circle back and take a look at maybe a little bit more detail. But essentially, one of the big things that's been brought up with these stairs is the fact that they have to have a maximum of 3 persons on that floor plate, floor area of what you're dealing with. So what does that mean? Well, it means if you have this spiral stair and you want it to be the only stair and you have it to a loft, well, you can only have 3 persons that are being served of that stair. Building code typically says you have 2 per bedroom when you're dealing with residential. So if you had 1 bedroom up there, it's a no-brainer. It's very easy. If you had 2 bedrooms, you're going to be told you can't have a spiral stair. Now, you could have that as the second stair. You would need to provide another code compliant stair. As soon as you step over that number 3, you have to provide a regular stair. But in this particular case, I think what you want to be careful of is 2 bedrooms is a no-no if this is the only one, even from a basement. Say it's the only way up from a basement or down from an attic. If you're dealing with a bedroom and a sitting area, or if you're dealing with a rec room, it gets a little bit confusing, right? How many people are going to be in this recreation room? How many people are going to be in this living room? I think you want to have some good conversations with the municipality on how you're going to restrict that occupant load and be realistic about it. You know, if you had a 20 by 20 family room and you're saying that it's restricted to 3 persons, I think that's a little bit unrealistic. So keep that note. If you're dealing with these spiral stairs and you want it to be the only way out off of a particular floor plate, then I think you need to say to yourself, okay, 1 bedroom is maximum. And if it's any more area than that, it's just not going to cut it. Now, these particular stairs also are very specific, you know, that single post with having that beautiful sort of cantilevered treads out from it. That's not good. It may work. I'm not a designer, so I haven't tried to figure this out to try to make something like that look. But what I've been told is really it's very difficult to have a center post spiral stair meet the code requirements. This particular example I have here on this slide is pretty much an example of what you would need. Handrails have to be on both sides with a 42-inch high handrail height. You got your clear width, which is a lot less. You got risers that are a little different changes in the risers, the treads, and a clear height of 1980 millimeters. So if you're a designer out there and you're able to make this work with a single post, good for you. And talk with your building official about it, how it's meeting it. But take a good look at these requirements if you're going to be proposing these, because this is restrictive on the 3 persons and it is fairly restrictive on how it's configured. You almost need to have a non-post 2-stringer situation, as I show on this particular slide. So great options for you, for designers and builders. We've seen them everywhere else, and for some reason, Ontario, we just could never have them. But now it's giving us some relaxation and allowing them in certain situations. All right, so those are the configuration changes. We got our new spiral stairs. We've got our new terms. We don't use angled treads anymore. We use tapered treads, right? So we're always using the new terminology as we're going through. Now we talk about really the big change. It's really one change. Maybe they brought us more changes because we couldn't talk about the one change for an hour. But anyways, I digress. We do have a major change with regards to stair dimension changes. And I do remember in my discussions with a few people that were involved in the changes is that these changes were to be brought in 2020. But the home builders basically said to the government, listen, if you add and make a stair a lot bigger, our lots and our subdivisions have all been laid out. Every inch matters. And if you're going to be adding some area to a floor plate, we need more time to get ready for this. So that was what I've been told was the reason why there was a 2-year delay on implementing these particular stair changes. And it was really because of this big change that we have happening that we've been used to for many, many years. And that's with regards to the run requirement. It has now been increased by 45 millimeters or 1 3/4 inches. That's huge. So instead of an 8 1/4 run, we now have to have a 10-inch run on our particular stair system. This can add up to 2.5 feet on an 8-foot high ceiling. So this isn't something that, number one, you don't want to miss. Because if this was under construction and done, how the heck are you going to add another 2'6" to your length of your stair? So you really want to make sure that if you're dealing with this particular provision, that it's dealt with. You're talking with your designers. Have you dealt with the new stair run requirements and taken up the more space that may be required? If you have certified models, that you have certain municipalities that have certified models, don't forget to call them and say, okay, we've got to update our certified model. That's the last thing you want, is thinking that you've got a certified model for a quicker approval. You kick through, and then all of a sudden you find you have to do a revision to your certified model that was approved last year. So make sure you're on top of the certified models and any, of course, of your future designs, that you're taking into account this additional 10-inch run, because it's going to make a big difference with regards to your stair plate. Now, there's been no changes to the stair rise. There's been no specific changes to tread depth, but I would like to sort of bring up another slide just to clarify it, because I know a lot of times you get people that get a little bit confused on the requirements of the code. So we now have this 10-inch required run, and run is defined from nosing to nosing. So the tip of the stair to the tip of the stair. And in this particular case, you can see with the two configurations, I have a particular stair that has absolutely no nosing, right? And the second one has a 1-inch nosing. And the way the code talks about it is it says that the depth of the tread can be no greater than its run plus an inch. So we could have an 11-inch tread. Which is probably what most stairs will have these days, because most stair configurations love to have that 1-inch stair nosing. But again, the 10-inch is the distance between nosing to nosing. The nosing requirements of 1 inch have not changed. So you want to make sure that you're going to add this additional 1.75 inches to any type of stair you're typically doing. But if you do have a stair that does not have a nosing, then of course it would be slightly different. So make sure that when you're sort of talking about that full tread depth, you understand the requirements of a nosing. So those were our rectangular treads. Very easy. Well, what happens when we get our tapered treads? Things that we don't call an angled tread anymore. We call it a tapered tread. Now on tapered treads, it's the same thing. No stair rise changes. The tread depth is the same, and the no changes to the minimum run, which is 150 millimeters. However, what it does do for us is say, hey, run's the same as a rectangular tread, but you measure it 300 millimeters or 12 inches from the inside of the handrail. So it's easy for us as inspectors. We can always remember the run now, but we just know that when we have an angled tread, we're going to measure that at 12 inches from the inside of the handrail. So it's been changed slightly there with regards to how we do our tapered treads. And of course, these standards are not applicable to winders or spiral stairs. They have a different requirement for these measurements. Now the stair might not meet the Ontario building code, but it was the perfect picture I could get to try to understand the concept. But the idea in this particular picture is that when you have tapered or rectangular treads, it must have a uniform run, except we're allowed at the bottom of the stair to exceed the run of the rectangular tread for our tapered treads to create more of a grander stair. So at the very bottom, you're allowed to do it. You can't do it at the top of the stair, but once you get to the bottom of the stair, you are allowed to sort of open things up a little bit to get that grand staircase that you're looking for. Added basically a slide to say what winders was before is what winders is again. They did not touch the requirements of winders in the building code, so we still have that maximum 3 steps, blah, 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 blah. Same sort of information with regards to winders. So those are big changes, especially those that 10 inches. That's a huge change that you want to make sure that you're dealing with. So designers, get your stairs designed there, change your applicable standard notes on your drawings, and of course, make sure you've provided enough room on the floor plate for this new stair. There was also some changes with regards to landings, which is also going to increase the size of your particular floor plate, depending on the configuration of stair that you're doing. Building code previously had a table in the code that basically talked about how the angle of the stair changed and applied the size of the landing. But essentially what the building code has done now with these changes is it's eliminated it and made one rule. If you have a 90-degree change at the landing, it's the same before. This is really the rule that they're following, is it has to be the minimum width of the stair is what it needs to be. So bang, 90-degree change, same as it was before. However, prior to, on a straight landing, you were able to reduce it to like 860 on an interior stair, but not anymore. Building code requires that 1100, the lesser of the minimum width, or 1100 for that particular landing. And that does also apply to the 90-degree. We've got to ensure that we have a larger landing. So they've increased the sizes of the landings. We don't get too many of these straight landings in the standard typical house. So you may not see this as being applicable unless you're dealing with 9, 10, 11, 12-foot ceilings. When you're dealing with a change, it used to have a difference between a 30 to 90 and a 0 to 30-degree change. And it allowed, again, a lesser requirement with regards to landings. You could get up to 270 millimeters. Not anymore. It's the lesser of the minimum width of the stair, or 1100. So you need to ensure that you have a larger landing. Where I can see this being an issue is I've seen some stairs that go along a garage that maybe has a 45-degree angle. And if you have a stair walk down from a garage down to the basement, that is where I've seen a couple of designers get caught, is that they aren't permitted to have these small landings anymore. And it really increases the space that they're going to need for these particular landings. So keep an eye out for those particular issues there. There was a few changes with regards to handrails and guards in the building code. So one of the things it talked about was handrails and tapered tread handrail location. It talks about the fact that stairs with tapered treads, or a mix of tapered and rectangular, shall have the handrail installed on the narrow end of the treads. So you can't, in this case, have the handrail on the outside of this particular stair. Sometimes it's the nicest place to put it. You know, you can just put a nice handrail along the stair, but you can't put it on the outside. I think the idea here is that when most people walk down a particular stair, they're going to be walking on the inside. The shortest path, of course. We always like to take the shortest path. So that's why I believe the building code has made it very clear that it wants to have the handrail on the inside. One big change that maybe we've always been used to all these years is that the height of the handrail has now been changed. And I think if you're with a stair company, you're probably pretty excited about this, because we always had the height of a guard being 1,070 millimeters, but the height of our handrail couldn't be any higher than 965. So it made for some interesting details with regards to how we were installing a handrail that's also a guard. You might have had to, you know, there's usually that gooseneck at the top, but now the building code has changed so that a handrail can go as high as 1,070. And of course, the minimum has not changed. So I think this does give you a little bit of more flexibility now in using the guard as a handrail, and without having any changes in height, massive changes in height due to the configuration. Of course, this doesn't apply to spiral stairs. It has its own requirements, but this will apply to most stairs that we're going to be dealing with. Small change, but a change that might be a pain in the butt. We're all used to the 2 inches or 50 millimeters between the inside of a handrail and the surface of a wall. Well, the code is changed to 60 millimeters if the surface is rough or abrasive. So again, we all love gray areas. So I think the idea here is what is rough? So is a brick wall rough? I'd say yes. Is a stucco wall rough? I'd say yes. But sometimes we get situations of what is rough. But I think in this situation, you want to make sure that if there is any type of abrasive surface, that you provide 60 millimeters. Probably don't make brackets 60 millimeters. You're probably going to have to provide some type of spacer or a piece of trim to bring it out that additional 10 millimeters or almost half an inch. So keep that in mind, is that they've kept it at 2 normally, but if it's a rough or abrasive surface, we don't want to scrape our knuckles. So they've increased it by another 10 millimeters for us, so we don't have that happen. Previously in the building code, it wasn't very clear that the prescriptive requirements of how to attach a handrail was also applicable to the exterior of a building. And so when we have handrails inside the building, the code is very clear prior to where you have the attachment points and where you attach it, what type of screws, all that was in the building code. But it didn't clarify that it was for exterior. So there was some discrepancies. Some were enforcing it, some were not. But the code has now made it very clear that the attachment of handrails, the prescriptive requirements, are also applicable to exterior handrails. This was an interesting change that was completely revoked from the building code. It talked about that if you had a stair, more than 2 risers, the sides of the stair ramp or landing around the stairwell shall be protected by guards if it's not protected by a wall. And the idea here is that, well, wait a minute, isn't 600 millimeters typically the height that we need a guard, but this needs it if it's 400? It just doesn't seem right. So the building code has taken this particular provision out. It must not have been in the national building code. So again, we're kind of following that 600 millimeter now. We don't have this special provision that forces it on a stair that is more than 400 or 2 risers. This isn't really specific to a house. And the building code defines a house as not more than 2 units, which is most buildings you're going to deal with. So this doesn't really apply to most single family housing with accessory apartments. But if you get into triplexes or quadplexes or something like that, when it has an attached garage, there is a requirement in the building code to provide a curb around an opening that goes into a basement. I guess the idea is that we get carbon monoxide or gases or fuel vapors or something that would get stuck inside this well that could cause a flammable issue. Well, previously it needed to be 150 millimeters, 6 inches. They've reduced that to 140. Not sure the reason for that, maybe practicality on how to build this particular curb, but they have reduced that particular provision to 140. But I think for possibly most of you, unless you're getting into the multiple residential, this would not be applicable. You happen to be doing some residential or some non-residential Part 9 buildings, and you've got some industrial spaces. Well, before it really didn't talk about the 3-pipe rail, which we see a lot in Part 3 of the building code with the larger buildings. Well, now it's specified how this is to be built, these 3-pipe rails. You need a top rail, and then you need 1 or more horizontal to ensure that you don't have a passage of a spear of greater than 21 inches. So that's the particular presentation that I have. That's all the changes that are in Part 9 of the building code. So we've talked about the new defined terms: why, what, when, and where, stair dimension changes, landings, handrails, and guards. Of course, we do our best here at RSM Building Consultants to provide you the best information that we know how, and we do that by providing you our opinions on these particular code provisions. But just make sure you double check with your municipality as you start working through these issues, because of course the chief building official in the municipality are the authority having jurisdiction. And so you want to make sure that anything that you're discussing with them is also is on the up and up with them. Do we have any questions on some of these provisions that we've talked about today?
You see one in the Q&A session there, Gerald. I think I was going to have Tara moderate some of the questions here for us. So if Tara's still around, then
yeah, I see there's one on here. Are we able to get a copy of this presentation? For sure. I have a PDF copy of this particular presentation. I'll be sending it off to Dieter and his team, and I'm sure they'll be able to share this with you, because yeah, went through it a little bit fast, step by step. You probably want to sit down, look over these changes. So we'll make sure that you get a copy of that for your notes.
Yeah, we'll
Sorry, I was typing a response there. So the entire Builders Forum this afternoon, we are recording the meeting, and so it will be available on the Town of Minto's YouTube channel for anybody who wants to look back on it.
Even better. Well, it looks like everyone's ready for the change. Well, I guess everyone should have been ready because as of January, everybody needed to have their applications in. But hopefully this clarified a few of the provisions so that when you are applying, you double check again to make sure that you catch all these items.
Okay. Well, if we're not seeing any further questions, I just want to thank you again, Gerald. I know that you're a strong supporter of this this event that we host, and we do appreciate you taking the time here again today to provide this information to everybody here in attendance. So thank you again, Gerald.
Thank you.
Yeah, very good. Okay, and we hope you stick around and take in the rest of the sessions that we have available as well.
Yeah, for sure. I'll stop sharing my screen here.
Okay, so moving on with our program, I'd like to turn the floor over here for a short moment to Aubrey LeBlanc with the Ontario Building Officials Association. Aubrey, the floor is yours for a few remarks if you wish.
Thanks very much, Dieter, and congratulations again to the chapter for putting on this very exemplary event, interfacing with the building industry. A big success every year, and this year as well. And thanks for making it all work during COVID and all the realities of it. I bring greetings from Joanne Beckett, the president of the OBOA, and the rest of the board. I think Terry Kuipers, amongst others, is in attendance as well. He's one of the directors of the corporation. We're in the process of working as a board on a renewed education strategy for the association and its members as we come out of COVID and move into a hybrid world. And so I think events such as this are a big piece of the kind of variety of things that we're trying to do with respect to the various relationships that we have, the constituents, the clients, and ourselves as building officials with respect to understanding building code related matters and enforcement matters. So we're really at a bit of a crossroads going into 2022 and the hybrid world. And so I think the kind of innovation that you folks practice with this event and the success that it's had will be, I think, still a big cornerstone of the kinds of strategies that we're going to be trying to support going forward. On the comments that Gerald made in particular about the building code, what he's gone over, of course, is one of the big topic areas within what is a very large set of changes that are coming up. So I think the idea of more building code changes than we've ever had before in sort of one period of time, that we're looking towards more of what Gerald has just provided to you. And in fact, we're going to be working closely with RSM in that process of providing, I think, a lot of code updating related information for members and for our clients going forward. So without further ado, I'll turn it back to you, Dieter, again with the thanks and the compliments of the board of the OBOA on yet another successful event.
Greatly appreciate it, Aubrey. Again, you taking your time here to be with us today and say those kind of remarks. We do appreciate that. And it does reflect down through everybody here in attendance that this is a strong event that our chapter has put forward for numerous years here. And it's that information sharing that allows consistent and appropriate delivery of building code services to the community and to the builders and designers in our world. So that's the reason why we're all here today. So again, thank you. And we'll continue on now with the rest of our program. We've got Will Taron with Tacoma Engineers. Again, Will's been another strong supporter of this event, and we look forward to hearing from Will next with respect to farm code building and new information changes and construction practices. So Will, I will turn the floor over to yourself now, and look forward to your presentation.
Thank you very much. Let me just get the presentation up on screen. I just confirm that you're seeing it in presentation mode.
I think you have maybe one more click of the mouse maybe, but we're very close for the presentation mode there. There we go.
There we go. Okay. Well, thank you very much. And as you alluded to, between these chapter meetings, and in particular the Bluewater chapter and the annual meetings, I think it's now over a decade that I've been involved in these presentations, specifically on farm buildings. It's not a subject that every OBOA member is involved with, but it is certainly critical to a clear group of the members. So just a little outline of what we'll do today, just a little bit of a introduction to Tacoma Engineers. I think I'll go through that pretty quickly. Most of you are probably familiar with the services and experience that we have. I'll then talk a little bit about the Farm Building Code and where we're going from there. I will then also talk about pressure treated posts or pressure treated wood in farm buildings. I do want to just preface that the comments on the pressure treated wood are my observations, my opinions. It is not a presentation from the Canadian Farm Builders Association, but my own research with other members, OBOA, builders, engineers, industry professionals, and code experts. And then clearly we'll have a session at the end with any questions and comments. At the same time, if there are questions during the presentation, please put them in the Q&A on the presentation platform. And if the moderators see them, please feel free to bring them up as we go. So Tacoma Engineers, hard to believe, it's back over 40 years now where Jack Tacoma started Tacoma Engineers here in Guelph. We've expanded progressively over the last 40 years. Now I have offices in Guelph, Barrie, and Waterloo with a staff of over 50 people. Our involvement in the farm building industry stretches virtually the entire 40 years of the firm. And we've proudly participated in that evolution of farm structures. I can appreciate that back in the early 80s, a large drive shed was sort of 40 or 60 feet wide, maybe 80 feet long. And now those are prescribed solution buildings. And as I say there at the bottom, we've been involved in the design and construction of over 2,500 agricultural projects. So diving into the code, my apologies to any of you who will find some of this repetitive. It has been a very long process that we've gone through, but the existing National Farm Building Code dates to 1995 with little to no updates since then. In fact, the former chair of the National Committee on it proposed a addendum in 1996, and it is still pending. So hopefully with the new edition, that will finally get picked up. So the issues really with the old code are they're not keeping up with current farm buildings. We talked about the size, the complexity of the buildings, and in reality, the provinces were losing confidence in the National Model Code. Manitoba many years ago looked to introduce farm building requirements into their code structure and looked at the National Farm Building Code and said, we can't use a document from 1995. So they defined all farm buildings as industrial buildings, typically an F2 building. Unfortunately, that put the brakes on almost all farm building construction in Manitoba for a period of over 3 years. They then rescinded that and created their own, and also are anxiously awaiting the new code coming out. A group of farm building industry started lobbying the federal government in 2006. And here we are today, 15 years later, over 100 meetings. 120 or 260 public review comments were received. I will tell you, it was endless days of meetings and analysis. It also really gave me a great perspective on codes and the public review process. I may have been cynical in the past that do these comments really get addressed? And I can tell you, every single public review comment that was received was addressed, was talked about within the joint task group, the standing committees. So the public review process is working very well. After all of that, I can say we finally now have a new code that's ready for modern farm buildings. The new code, which will be issued as part of the National Building Code 2020, maintains the definition of farm buildings, the unique definition for farm buildings, recognizing the characteristics, the low human occupancy, and gives them the accommodations for life safety, building size and materials, means of egress, firefighting requirements, design loads, and more recently, requirements on ventilation. Backing up here, as you saw from the outset, there was a green sheet, a green document that many of you were familiar with. That was the standalone National Farm Building Code. That document will no longer exist, and farm building requirements are going to be integrated directly into the National Building Code as Part 2. The benefits of that is all working professionals then would be expected to have copies of that. Building officials, building departments in rural and in urban settings will be familiar with the concept of farm buildings, low human occupancy. So there will be a much broader and uniform adoption of those requirements. Within Part 2, it will be broken into 4 parts. A general, a section on fire protection and occupant safety, very much like Part 3. A section on structural loads and procedures, very much like Part 4, and HVAC, very much like Part 6. I believe that's correct. Not my specific area of expertise, but certainly this new Part 4 was modeled after the former National Farm Building Code, plus NBC Part 3 and Part 4. One of the prime differences between the NBC general requirements and those for farm buildings is only the OS objectives, the safety objectives applied to farm buildings. The property objectives do not apply. And as every single clause in the new code was written, drafted, and reviewed, a reference back to objectives and function statements is absolutely required. So you will see some changes as we move forward here that are specific and changed because of the objective statements. So going through NBC Part 2, very much like the old code, this only applies to farm buildings of low human occupancy and those located on farmland, which means that greenhouses or other farm structures in an urban environment are not farm buildings. Also, industrial facilities located on farmlands are not farm buildings. They need they need to look like farm buildings and operate as farm buildings. Within those farm buildings, they're broken down into four categories or divisions. The G1 high hazard farm buildings, G2 a standard farm building, G3 specific to greenhouses, and G4 may be a bit of an oxymoron, but it's a building with no human occupancy. That really gets into some of the storage facilities that are typical on farms. Within Part 2, the fire protection, the single biggest change in the code is that a standard G2 farm building may be up to 3 stories of combustible construction and of unlimited area. What everyone was accustomed to 4,800 square meters has been removed. And again, that goes to the comments that the property objectives don't apply and only the safety. And when you apply the exiting requirements, no longer need the other portions. Sorry, I was being interrupted there with a. In addition, fire detection is required in all farm buildings with 2 or more stories. And for years, we've talked about multiple major occupancies in buildings, and it has been really contentious with farm markets, assembly occupancies, and others. I can now tell you that the new code clearly defines and puts limitations and restrictions on multiple major occupancies. In terms of fire protection, as we alluded to earlier, fire department access is required at all farm buildings, as is emergency lighting with backup power. Exits also now need to be clearly identified or signed, and overhead doors are no longer allowed as defined exits. Very much similar to previous editions of the Farm Building Code, fire separations are required between many high hazard areas. But in the attics, the spacing of attic fire blocks is no longer based on a linear measure, but areas. We then also will get into ventilation requirements, and one contentious issue and may be subject to revision moving forward is all of the spatial separation requirements have been removed from the code because the only objective statements that could be applied to those were the property and not the safety. That is open for debate, I recognize, and I can tell you that there are probably some changes coming in the future. In terms of structural design, very much as per the previous codes, but it's been greatly simplified. The underlying statement is that farms are designed as per Part 4, with the exception of the specific requirements listed here and throughout the code. Increased loads for large farm machinery, discussions about manure tanks, bins and silos have been removed out into the structural commentary. I recognize I'm going through this very quickly. It's a bit of a repeat for many of you. I'm happy to answer questions at any time as we move forward. The concept of snow design has been maintained from the previous version of the codes, but it has moved now to a 50-year return period, and the system factor for trusses has been removed. Essentially, that means we're going to be seeing trusses installed at 2 feet on center rather than 4 feet on center. That came directly from the Canadian Standards Association recommendation. There's also been some updates about roof snow loads on greenhouses, a slight increase, but also a requirement that there's a minimum heating that can maintain 10 degrees centigrade in the building with full backup power. The wind loads are one of the biggest structural changes. We're going from a 1 in 10 year to a 1 in 50 year return period. That's about a 50% increase in the wind load that the farm buildings need to resist. That's a reflection of climate change, also some localized failures we've seen with some of the extreme weather on wind. Seismic is another item that has bounced back and forth many, many times. Some advocated that the status quo of no seismic design apply to farm buildings. Others wanted all buildings subject to seismic design. In the end, a hybrid solution was developed. That the default is that seismic design is required, but there's 2 major exceptions. One, if you're in an area of very low seismic activity, and I can report that most of Southwestern Ontario will fall into that. So if a building is in a very low seismic activity area called SC1, seismic category 1, it will be exempt. If you're into a low seismic area, SC2, and have high ductility on your building, which means it has flexibility, you again will be exempt. For that screening, you can use a class site D in your analysis. All other buildings will need to go through seismic design. From personal experience and some modeling I've done, even though seismic design will be required as a design criteria. Wind will still govern for the vast majority of those buildings. Final few things on structural design. The importance factor will be maintained at 0.8, recognizing low human occupancy, but allowable stress design really not been used much since the 90s. It has actually been now removed from code. Also, the old National Farm Building Code had specific load testing criteria. That has been removed, and any load testing that's required needs to be done as per the CSA standards. One of the last items here is ventilation. As I mentioned, high hazard farm buildings are a special category, and any barn with a manure storage below the floor is considered a high hazard farm building. But with this requirement, 2.4 on ventilation introduced, those buildings actually get their criteria reduced down to what's equivalent to a regular farm building. So there will be mandated 2 air exchanges per hour. All of those liquid storage manure storages will need to be ventilated with the appropriate design criteria. Silos, feed bunks, those items have been removed specifically from the National Building Code and introduced into the structural commentaries. And many of those, in fact, now are referencing American standards because unfortunately, with cutbacks, there is no or very little original research being done in Canada. So it was best to rely on the American standards that are updated on a regular basis. That was the building code. Now to the fire code. Most people on this, yes.
Sorry, we do, I know that you mentioned in our pre-session there, but we do have a question in the Q&A. So if we could just maybe look at that before we move along. So the question comes from Mark Diebel. Will the change to farm buildings be designed to Part 4 mean that all farm buildings, regardless of size, will require a P-Eng stamp?
My apologies, it may have been in the notes earlier. This only applies to large farm buildings. And that definition uses the definition from the balance of the code, essentially 600 square meters. I will get to the small farm buildings as a small comment at the end, but all my previous comments were with respect to large farm buildings, 600 square meters and bigger.
And we had one other question pop up here from Jonathan DeWord. Will there be changes to the standards for stave silos?
All of the silo design will be as per the ASAE standards. So yes, there will be, recognizing that these are generally designed by the manufacturers with specialty engineers. They will be, and most of them actually have been relying on the ASAE standards. So I don't expect to see significant changes, but the new standards will be the American standards. I hope that answered the questions. If there's anything more on those, please put it into the Q&A and I'll be happy to talk about it. So everything up to now has been the National Building Code 2020. What I'm about to talk here is about the National Fire Code. As you are very likely aware, the Ontario Building Code exempts farm buildings from the fire code. The hope of the national bodies are there'll be uniformity across the country and the fire code will apply to farm buildings. Again, that will be subject to a decision made by the Ontario government. Many believe having the fire code apply to farm buildings is one of the greatest steps that can be made to increase safety, in particular fires on farm buildings. As you've seen in many other presentations, housekeeping, electrical, mechanical systems is one of the biggest issues.
Well, we have another question here.
Yes.
Can you give some examples of other G1 high hazard farm buildings from Terry?
feed bins, feed mills are top of mind. Some where there's storage of fertilizers would fall into that. Storage of flammable materials. I don't have the list in front of me, but they are defined within the Farm Building Code. Distilleries are not part of that, but some other vinicultures may fall into the higher hazard farm buildings. So the National Fire Code was updated for farm buildings. It parallels a lot of what's in the building code, including restrictions on major occupancies, items that seem second nature, but theaters, arenas, pools aren't allowed in farm buildings. Confinement or restricted access facilities, not allowed in farm buildings. Electrical clarification that electrical codes apply and that the electrical service is to be designed for both wet and corrosive environments. It also puts requirements for inspections by qualified individuals for every 12 months for livestock barns and every 3 years for other farm buildings. Those inspections every 3 years are to include thermographic inspections. Records must be kept and repairs must be undertaken. The biggest item that comes out of this is the fire code is retroactively applicable. I've got that coming up here. The building code isn't. Buildings can be grandfathered, but the fire code can be. So as operations change, these can kick in. Similar to the electrical, mechanical. Minimum requirements to reduce fire hazards, inspections, repairs, and maintenance are absolutely required. Again, more enforcement ability for warning signs, gas and vapor control, ventilation requirements, and flammable liquid storage. All of those fall within the fire code. And if in Ontario, the fire code is made applicable to farm buildings, it can be enacted retroactively and enforced. So what are the next steps here in Ontario? What I can tell you is part 2 of the NBC has been fully approved, including the commentaries. It's been updated since there. It is now fully ready as a national model code and is expected to be issued in Q1 of 2022. The only reason is it's not out yet is the entire national building code was held up after there were some discussions about energy conservation. So, but I believe that's getting clarified. There's probably people on this call who are more aware of when that publication date will be. But in advance of the NBC coming out formally, Ontario has actually already adopted all of the proposed NBC requirements as provincial requirements. And we have actually just finished the first round of public consultation on farm buildings, which was included in round 2 of the public review. There is one final public review process slated for later this year. From what I can tell, the new OBC is intended to be issued in 2023 with an effective date of 2024. Again, if anyone on this call has better information on those publication dates, be wonderful for people to share. And alluding to the previous question on the large and small farm buildings, these new changes in the NBC only apply to large farm buildings. Small farm buildings in Ontario, the assumption is that SB 11 will be maintained. And in fact, there is a strong push that the SB 11 be adopted nationwide to replace the existing requirements of small farm buildings.
Well, we have another question here
Yes.
from Mr. Don Tedford. What do you mean by saying that the NFC can be retroactive? Is it only certain sections?
We are, again, the fire code can be applied to all buildings, all standing buildings. The fire prevention officers, fire marshal's office can go into existing buildings. They can issue warrants, they can issue orders to comply, while the building code is not as loose and retroactively applicable.
Okay, thanks. We have another one from Nicole Coles. Is residential permitted attached to a livestock barn?
Sorry, can you repeat that again?
Is residential permitted when attached to a livestock barn? Current codes does not seem to speak to this.
The new code does speak to it. You're likely all very familiar with the code, with the table in part 3 that shows all of the classifications in a large table, you know, a D next to an F2. What's the fire separation requirements? There's the same table for farm buildings. So if you have a G2 next to a C, a 1 hour fire separation, I believe is the requirement. Please don't quote me. I don't have the table in front of me, but every adjacent major occupancy has defined fire separation requirements, from no rating required to a specific rating required to it not being permitted. Anything else on the building code side of things? The new farm building code? I'll take that no for right now and move into pole frame farm buildings. Pole barns really have been the go-to framing system for farm structures for over 50 years. Wasn't much I could say more than that. They're ubiquitous across the province, whether it's a drive-in shed, original barns, equipment storage, hay storage. In early days, they were quite informal, often using nothing more than a good straight tree or old utility poles. And more recently, I'm sure we've all seen pictures, and certainly if you're a member of the Canadian Farm Builders Association, you've seen some of these multi-million-dollar horse palaces, as we friendly term that we use for them. Really, the pole frame building has been very well received. It represents a really efficient use of materials, simplicity of design and construction, functionality, and there was always an assumption of high durability. You know, the drawing down at the bottom was a Canada Plan Service drawing from the mid-70s. And with the exception of a few nuanced changes, that building design is as applicable today as it was in 1972 when Canada Plan Service put that drawing out there. Unfortunately, in the last few years, there have been increasing concerns about the durability of wood posts. We've had stories of posts in particular rotting out sooner than expected. And you can see there, this was an article in Better Farming magazine by Becky Dumais in February, actually distributed to, I think it's 40,000 members of the Ontario Farmers Association. So I think the message is out there, getting out there, questioning some of the durability issues. So I think it's a subject that all of us need to address, be it builders, designers, specifiers, and building officials. Much of this started out after a local builder reached out to me and the industry associations. He was called out to a farm. The farmer assumed that 2 posts in the corner were subject to frost jacking and had lifted. It was binding all the doors, etc. On a little bit further investigation, it found out that in fact that corner wasn't heaving. It was the balance of the posts on the barn had settled 2 inches. And when digging them up, this is what he found. In fact, complete rot through on many of the posts only after 12 years. And in this case, these 6x8 posts was full penetration decay. After hearing that and a little leery maybe of the underlying or the backstory, I reached out to many other builders, and almost without exception, they all had premature deterioration on wood barns, some of them less than 10 years old, required full or partial post replacements.
Hi, Will.
Yes.
Looks like Cedric has his hand up here.
Okay.
There, I am allowing you to talk there, Cedric.
No, sorry, that was a mistake. Yeah.
Oh, okay. Thank you.
Can continue. Sorry.
Not a problem. But Cedric, if you do have any questions, please feel free, or anyone else. I'd prefer this more as an open dialogue. This really is sharing the information that we've received. So as an industry together, we can all move forward and find solutions. So we all can have safe and durable farm buildings. So there were a number of assumptions that were made immediately, that either the posts weren't treated or were installed in very adverse condition. In this particular case, it was confirmed that the post had end tags that identified ground contact. And the barn, in fact, that is a picture of the barn during construction. It was on high ground in relatively dry, sandy conditions. What we did identify is that the treatments or the chemicals changed in the early 2000s, and the Pest Management Association restricted the use of CCA treatment chemicals in the retail industry. We've had many discussions with the industry, and what came clear in that is there is a very clear distinction between residential and commercial wood products. And I will read here, you can all see it, but pressure treated wood sold at local retailers is for residential applications such as decks, fences, and pergolas. For commercial, such as barns, please note pressure treated wood must be purchased through special order, either at the retail location or directly from the treating facility. The posts are not the same. Now, unfortunately, we identified this very important distinction, but found that very few specifiers, very few suppliers were aware of this distinction. We reached out to local lumber yards. The vast majority of them said, no, there's no difference. You know, this is pressure treated, and even look, the end tag says it's for use in ground contact. Also going through the regulations, CSA guidelines, regulations, industry guidelines and regulations, we found that many of the terms used are ambiguous at best. So this goes through and not applicable to here, but this is the residential system. And it is based on product groups and not the UC use classification as defined by CSA. These are for residential only. And in fact, right in the guidelines, there is no specific requirements for retention of the treatment material, for penetration of the material. And the only standard that really is to meet the residential customer's expectations. To me, that loose terminology is somewhat less than satisfactory, but these product groups are permitted for residential construction. The codes allow it, but it is clear that they are not suitable for commercial construction, of which agricultural construction is part. What you do need is then to use commercial grade wood that is intended for in-ground use. And those are defined by use category 4.1 and use category 4.2. The main distinction between those two are twofold. One is based on the potential for decay. There are low decay areas and high decay areas. Unfortunately, the definition of low and high decay areas is not defined. It is left as loose as the word high decay and low decay. The other item identified is that you see any post, or I'll move forward, but any post that is defined as a critical building element, UC 4.2 is the requirement. So the takeaways here and the next steps really come down to education, clarity on the industry specifications, questions around availability. As we've reached out, there are a few local sources that can bring in the UC 4.2, but we have yet to identify anyone who can bring in a reliable source of UC 4.2 treated lumber. And based on our research and interpretation of the CSA requirements, UC 4.2 is the requirement for critical elements in farm buildings. To me, that would be the load-bearing posts. Interior posts, fences, UC 4.1 would be acceptable, but I see UC 4.2 as the acceptable standard for farm buildings. So again, availability will be really a main issue. We have been looking at alternatives, and I can tell you that Tacoma Engineers, for one, I know of 3 other engineering firms who have in fact put a moratorium on designing and specifying barns with in-ground posts. And we are designing all of our pole buildings with either a frost wall or unique round piers, square or round piers, keeping the wood up out of the ground. The last item, yes.
Sorry, we have another question here
Yes.
from Dawn. So as inspectors and plans reviewers, would or should we be asking for manufacturing confirmation for commercial buildings?
I would think that would be very prudent. Again, if we apply the requirements of the building code and follow that through to the CSA requirements for farm buildings, UC 4.1 and UC 4.2 are the commercial grades. The information published by the Canadian Wood Council, Wood Preservation Canada, CSA all make it very clear that there is a distinction between residential and commercial grade lumber, and that residential grade lumber is not suitable for farm buildings.
Okay, we
Just
have
going
one more
on, then the final comment here, really the education about lumber grades for farm buildings is absolutely imperative. I know there are more presentations coming. This presentation here, again, is to share some of those items and to at least make everyone aware of the conditions that are out there, the fact that we are seeing premature deterioration of poles, which for every reason should look like they would be successful, but they're not. There has not been research done, to the best of my knowledge, with the change in chemicals that was in the early 2000s. But talking with industry professionals, including those in the treatment industry, all believe that if the posts were still treated with CCA chemicals, they would be fine and were fine in the past. But the new chemicals are not as robust, and therefore absolutely imperative that we get the commercial grade posts that have the higher retention volumes and the the deeper penetration. Sorry, I'm gonna slide back here. I think I slipped over. No, my apologies. I'm missing a slide here. There is a clear slide that shows what the stamp for commercial needs to be. And
Well,
it comes straight out of the CSA standards. It's not an end tag. It is a stamp right on the lumber. Yeah, my apologies. That slide has fallen off here. It needs to identify those and needs to be stamped right on it. It needs to identify the plant that certified it, what the chemical is. It has to identify that it is to UC 4.1 or 4.2. It has to show what the retention is, and one other requirement. I'm sorry that the end here was a little haphazard. Happy to answer any questions on codes and lumber.
So there's a couple more here. Some Mark Diebel, should UC 4.2 also be used for posts and plates in contact with concrete, such as a dairy barn along the curtain wall?
That's an item that is not well defined and again, a bit ambiguous. My interpretation is that UC 4.1 would be suitable. It is the direct in-ground contact that is of greatest concern.
Okay.
But still, the sill plate should be commercial grade, not the residential product classes, but either UC 4.1 or 4.2 as appropriate.
Thank you. Darren, is there any additional coatings that could be added, such as tar or other products that would be acceptable?
The Wood Preservation Canada has their guidelines out there. Certainly all penetrations, all cuts need to be coated, and it needs to be coated with the materials recommended by the industry. Do I think putting a tar coating on a member may provide enhanced durability? I think it probably would, but that's not compliant with CSA requirements and the manufacturer's recommendations.
Okay. Kirk, is there going to be washroom requirements within farm buildings? For instance, if a farm building is for animals and for people to visit the farm building to view the animals or to purchase farm products?
I do not recall any requirements for washroom facilities in farm buildings.
Okay. Howard, is there any information about the effects of pressure treated posts going into gravel as opposed to concrete?
I don't know if there is any specific research. I know that Wood Preservation Canada has done a lot of research. In fact, they have a field, and if any of you saw the article in Better Farming, they have a field that is full of posts. Some of those posts have been in for 50 years, and they continue to monitor and research. Unfortunately, the definition of low decay environments and high decay environments is not well defined. I wish it was. I can share with you that we have asked the industry for that definition, and to date that's not been supplied. Hopefully in the future, clearer definition of high and low will be provided. That being said, the CSA definitions for UC 4.2, all critical building components, the only area for critical building components is UC 4.2, but unfortunately those posts aren't readily available in Ontario. It's not a good situation that we're finding ourselves in, that if we want to conform with the CSA requirements, it points us to a material that's not readily available at project type lots. There's lots of discussion of saying, yes, those posts can be made. You know, there's suppliers that can send a train load from, you know, any number of areas, but I don't yet know of an Ontario supplier of sort of 6x6, 6x8, 8x8s in project lot sizes that can supply them into our industry.
Okay. Don had asked earlier, he just wants some more clarification on the retroactive requirements.
That might be best answered by another code expert on this page, on this discussion. It falls not specific to farm buildings, but throughout the building code of building codes apply to when a building is designed, but can't be applied retroactively, but the farm code can be. Dieter, do you want to comment, or do we want to call Gerald or someone else in to comment on that concept?
My comment would be that we'd have to kind of reach out and look at that. If Gerald wishes to provide anything here, he can gladly speak as well.
I think the way I've always looked at fire code is it's applicable to existing buildings, which I think is what Will is making clear, is that when that comes in place, fire code needs to be in compliance because it's existing buildings. I think that's a general statement that we all look at with regards to the fire code. I don't think it's specific to farm.
It's not specific to farms, except right now farm buildings are exempt from the Ontario Fire Code. The desire of the National Research Council and Codes Canada is that there's uniformity across the country, and when the new OBC, which uses the national model codes for farm buildings, that exemption would be lifted and the fire code would apply to farm buildings in Ontario.
Okay, I'm not seeing any more questions in the question chat. I don't see any hands up here. I think we may be done for questions.
Just to add to that, it is an interesting piece to transition from a former area of the fire code that was all for farm buildings being exempt to now applying it. So how far, you know, this could have great effects on a lot of structures where there were some exemptions that were permitted in the past. So it's an area that will be of focus and attention needed, but just something that we should all be diligent on if we're a building official and being a part of some of those inspections that are completed and being asked questions.
So Don made another comment here. So the NFBC will not be retro.
It would be the same as all other codes and not retroactively applicable unless you're dealing with an addition or modification. The same as you would apply any other portions of the code.
Thanks, Will. That's all I see for questions.
Thanks, Will, for taking the time here this afternoon and providing us with your presentation and information. That was, again, well-informed information to be sharing and something to take home for all of us here again. So thank you for participating with us today.
Thank you to you, Dieter. Thank you to everyone who's has put this on. These are outstanding sessions, informative and entertaining. Thank you.
Okay, moving on to our next session here. Mike Gibbs is available to us from the Ontario Onsite Wastewater Association, and I will leave a few remarks to Mike here before we get into the prepared presentation that we will be broadcasting that's been provided to us by the Ontario Onsite Wastewater Association. Mike, floor is yours.
Great, thanks, Dieter. Yeah, and thanks for having me here. We've been doing these sand filter bed presentations to a number of OBOA chapters in the last year or so, and seems to be a lot of interest in this particular one. Sand filter beds seem to be one of the more common types of septic systems or conventional systems that are installed in Ontario. But we are working on some more of these types of presentations to be shared with that are geared towards regulators of Part 8, and that will cover other subject matter. I'll just take a second to introduce the association. We are the provincial professional association that represents, building officials, Part 8 regulators, installers, system designers, engineers, manufacturers, suppliers, pumpers, and service providers of septic systems, and kind of we're seeing more smaller municipal systems, or what we call communal or decentralized systems in Ontario. So we cover a wide range of professionals in the industry. So if you're a Part 8 practitioner and not a member of UA, I suggest you join the association. We have a number of resources available to help you enforce Part 8 of the code. I just want to also bring your attention to some of the resources that we have available, some of which are guidance documents, which is are produced by our on-site technical committee. And those are available on our website, www.oowa.org. You can find them under our industry resources, and they're best practice documents or guidance documents, and we have a number of them relating to inspections, pump chambers, shallow buried trenches, like I said, sand filter beds as well, and a few others. So some handy resources there for you folks. We also have this brochure that we produced for homeowners. I don't know if you can see that. I guess not with the camera. Anyway, it's a handy brochure, triplicate fold that we've made for basically anybody. I mean, if you're working in a municipal office, these would be pretty handy for anybody coming into for a permit. But anyway, just a kind of a basic septic 101 handy resource to hand out to homeowners. The other thing that we've done as well is another video that we've done just recently called Septic System Basics for Homeowners, and that's available on our YouTube channel. So if you're on YouTube and you Google, or not, but if you're on YouTube and search for Ontario On-Site Wastewater Association, you'll find that video there. And we're happy for municipalities to have that on their website, to share that link around as widely as possible, because it's just some really good, just some basics, basic awareness information for homeowners. So please share that widely. And then as well, we've just wrapped up our virtual convention again for this year. Second year we've had to do that, but we have the virtual convention, all the presentations that were pre-recorded on our website. You can go to our events tab and you can still register and check out all the presentations. We've got a couple of really good presentations that were geared for regulators. One by Terry Davidson and Eric Colesmith from the Ottawa Septic System Office, that are geared towards regulators that pertain to maintenance contracts, and Terry's experience with maintenance contracts for septic systems. And Eric has kind of given a bit of an overview and some insight into the permitting process. So for those of you who are just new to Part 8, Eric kind of goes through a step-by-step process on kind of the permitting process and some of the ins and outs of that. So sorry to be so wordy, but anyway, I just want to make sure that you knew who UA was and some of the resources that we have available for our members. Without further ado, I'll introduce the pre-recorded session. This was done by Ann Egan, who's our past president, and she's the chair of our on-site technical committee. We were getting a lot of questions, a lot of inquiries regarding some of the basics around sand filter beds. So we decided to kind of put something together in that regard. And Anne is also, I should mention, is an engineer, and she's the manager of the wastewater on-site wastewater services for RJ Burnside. She's based out in Mississauga. So Anne's been a long time UA member, and like I said, past president now with the association. So she's my go-to code expert when I have questions that I can't I don't have the technical expertise to deal with from members. So anyway, she's quite a valuable resource. So anyway, Dieter, if I can hand it over to you at this point, I want to hit play on that. I should say, actually, we normally have during these presentations, we would either have Anne or Bill Goodale, who some of you may know, was a Part 8 regulator up in Tiny Township, to be present for a live Q&A after the presentation. Unfortunately, neither of them were available. So if you do have any questions about this presentation, please feel free to email me and I can forward them along to Anne or Bill and we can get them answered for you. My email address is outreach@oowa.org. So again, if you have any questions, just please fire me an email, or you can get my phone number off the website. So so without further ado, Dieter, if you want to hit play on that, that'd be great. And thanks for the opportunity for us to be to present and to be here. So.
Nope, you're very welcome, Mike. Thank you for the introduction on what OWA offers for services. So I will try and get the video going here shortly.
Thanks.
Mike, can you just confirm that you can see my screen there with the presentation?
Yeah, I can see the presentation. Yeah, they might just want to. We've had some tricks with the sound in the past, but maybe let's just try the sound.
Very good. I'll try and play here and hope for the best.
Yeah, so the sound, there may be something that you need to hit on your. Are we on Teams right now or Zoom?
We're on Zoom. Was there no audio?
Oh, there's audio. Yeah, Anne is narrating the slides as she goes through it, so there should be audio there.
Okay. No, I could hear it through my speakers. I just wasn't sure on.
Yeah, you may just have to. I'm not sure what would be on your end as to.
Dieter, it's Mark Diebel here.
Yes.
When you go to share on Zoom, when you go to share it, make sure you have share audio clicked on.
That's what it is. Yeah. Thanks, Mark.
You're welcome.
Okay, just bear with me here for a minute.
So while you're doing that, Dieter, if it's okay, I'll go prattle on about something else that we've been doing as well. That's being well received by our members. We've been doing these Part 8 panel discussions on Zoom. And so this is where we have an installer, we'll have a system designer or an engineer, and then we'll have a regulator on a panel. And we'll come up with some issues from Part 8 that aren't necessarily clear, or that people have a hard time with, or that isn't being consistently interpreted across the province. So we bring those topics to the panel, and the panel will have a discussion, and then we'll open it up to a Q&A. So those are being quite well received, and yeah, a lot of people really find them really useful. So just another thing to think about and to stay in touch with about. We do them on a quarterly basis. So we have one coming up in the spring session. So anyway, just another point there.
I think I may have found the magic button there, so I'll try again here.
Considerations for filter beds, presented by the Ontario On-Site Wastewater Association. This presentation will discuss the use of filter beds. First, we will do a quick review of soil-based treatment systems. Then we'll talk about filter beds, their origins, the system components, and some examples of sizing for a filter bed. We'll talk about the filter sand specifications, loading
My apologies, just having connection issues, sorry.
Are you having a problem with the presentation, Dieter, or is it just connectivity? Oh, there you go.
Presented by the Ontario On-Site Wastewater Association. This presentation will discuss the use of filter beds. First, we will do a quick review of soil-based treatment systems. Then we'll talk about filter beds, their origins, the system components, and some examples of sizing for a filter bed. We'll talk about the filter sand specifications, loading rates, in-ground versus raised filter beds, and there will be time at the end for a discussion and question and answer period. With a standard septic tank and leaching bed system, the most important part of the system is the leaching bed, where approximately 70% of the treatment occurs. The leaching bed provides two primary functions, one being the treatment of the effluent through the soil, and the other is that it provides a method of absorbing the liquid into the underlying and surrounding soils without breakout. In Ontario, we have different types of leaching beds available to us. There's the conventional absorption trench bed, we have filter beds, and we also have Type A, Type B dispersal beds, and shallow-buried trenches, with these three being permitted to be used only in conjunction with an approved treatment unit. We also have combined treatment and dispersal systems, which are not currently in the building code, but are authorized through individual Building Materials and Evaluation Commission authorizations. The leaching bed provides treatment through a combination of physical, biological, and chemical means. So in physical treatment, we do get physical filtration of the effluent through the soil particles. Biological treatment occurs because microbes in the biomat and the soil consume the organics and the nutrients and assist with pathogen removal. And we get chemical reactions between the constituents in the effluent and the soil, depending on the type of soil. The other primary function of the leaching bed is to absorb the effluent into the underlying and surrounding soil. So the leaching bed has to have sufficient area to allow this to occur. This is going to be dependent on your underlying soil properties and your site conditions. So as required by the building code, a site evaluation would look at these things as part of the design work. So you would need to have an understanding of the soil physical properties of the site and looking at the soil profile. So what are the different layers in the soil, and is there a limiting layer such as a high groundwater table, bedrock, or a low permeability soil that is going to dictate how the effluent moves in the ground. Conditions can be variable even on a given site, so it's important to have site-specific information for all installations. In the design of any leaching bed system, it's important to understand the soil profile. We need to understand how the effluent is going to move through the soil when discharged to the bed. So we need to look at the soil profile. This is a vertical section through the subsoil, and it shows the different thickness and sequence of the soil layers. This is going to be unique for each site, and you have to consider these different layers. What is going to be the limiting layer? What is going to be the direction that the effluent will move through the soil? How will the effluent move through the different layers? And you have to consider both vertical and horizontal movement. The filter bed is a very popular type of leaching bed used in Ontario. So let's discuss the origins of this type of leaching bed. The filter bed was studied in the 1970s by the Ministry of the Environment by a fellow named Chowdhury. And the original purpose of this was to look at a sand filter as an alternative to a conventional subsurface trenches. So this excerpt comes from the report by Chowdhury on his studies. In the introduction it says, the sand filter is considered to be an efficient device for the treatment of household sewage in areas where conventional subsurface disposal methods are impractical. So this study looked at under-drained sand filters, and they looked at 5 different grades of filter sand, so from a very fine sand to a pea gravel. And so they were primarily studying the treatment function of this sand filter and how the different grades of sand performed. So the Chowdhury studies looked at different gradations of sand and gravel, and they concluded that a 750 millimeter depth under-drained sand filter would provide effective treatment for BOD, TSS, and some coliform removal. They did find that the finer sands tended to clog more easily, and the coarser gravels didn't provide adequate treatment. And that is how they came up with the specifications for filter sand. So in the 1982 MOE Green Book, the Manual of Policies, Procedures and Guidelines for On-Site Sewage Systems, Section 8.7.5 of that guideline describes the use of filter-type leaching beds, and that subsequently became Section 875 of the Ontario Building Code. So it's important to remember that the filter bed provides the treatment. So this is a sand filter providing treatment of the effluent. But if you recall, we discussed there are 2 functions of a leaching bed. One is to treat, and the other is to provide dispersal or absorption into the underlying soils. So any design needs to consider the hydraulic loading to the underlying soil to make sure that there's enough area in this filter bed to properly disperse the effluent at a rate that the underlying soil can accept. It's also important to remember that filter beds are smaller than trench beds, and they do concentrate the same volume of effluent into a smaller area. So this is important when sizing a filter bed and giving consideration to providing adequate treatment and adequate dispersal into the underlying soils. Section 8.75 of the Ontario Building Code describes the requirements for filter beds. And there are some size limitations for filter beds. Now, because we are concentrating this volume of effluent into a smaller area, there are some limitations. To make sure that we're getting proper treatment, filter beds are permitted to be used up to 5,000 liters a day, where the treatment unit is a septic tank, or up to 10,000 liters a day if a level 2, 3, or 4 treatment unit is used in conjunction with the filter bed. There's also a loading requirement that the filter surface must be at least 10 square meters but not exceed 50 square meters. And again, this is important to remember that the filter bed is providing treatment. If we have too large of a filter, it may not get good distribution and good treatment through that filter. When considering the design of a filter bed, there are 3 main components to consider in the sizing. You have your distribution layer, constructed of either a stone and pipe or chambers, which will distribute the effluent over the surface of the sand filter. The distribution layer would be sized based on an area of Q/75 if your design flow is less than or equal to 3,000 liters a day, or Q/50 for a design flow greater than 3,000 liters a day. The second part of the filter bed will be your sand filter and your extended contact area. This part of the filter bed is the main treatment component, so this must be constructed of filter sand that meets the specifications in OBC 8753 sentence 3. And this again comes from the Chowdhury studies, where they looked at the different gradations of sand and gravel materials, and this was the gradation that they found performed the best. It provided the best combination of treatment, but also movement of the effluent through the soil. so it was coarse enough to allow the effluent to drain freely, but it was fine enough to provide adequate treatment. So the sand filter area has to have a minimum size of QT over 850. And it's important to note that that T is the T time of the underlying soil. The third component of the filter bed is going to be your total loading area. So we have to look at table 8741 for any fill-based leaching bed system, and a filter bed is almost always going to be a fill-based system. You have to have a loading area that meets the loading requirements in that table. This drawing just shows a typical cross-section through a raised filter bed. So in this section, you can see the different components of the filter bed. You have your distribution layer, which in this case is a stone and pipe layer that distributes the effluent over the surface of the sand filter. You have your filter sand, which extends to a depth of 750 millimeters minimum thickness below the distribution layer, and the base of that filter sand extends to cover the area that is calculated by that QT over 850 relationship. And then you have your total loading area. So this is calculated based on the loading rate tables in 8741 of the code, and that provides your total base contact area between the imported material of the filter bed and the underlying soil material. And that loading area can encompass your side slopes and your mantle, so your extended 15-meter sand mantle that goes downstream of your distribution piping can be part of your total loading area. You can see in this sketch that we've shown that the sand that's used for the loading area does not necessarily need to be filter sand, but it can be so long as you have your minimum filter sand area that meets the minimum QT over 850 size requirement. You could use a different sand fill to make up the rest of that loading area. This slide walks through an example of how to size a filter bed based on underlying soils with a T time of 25 minutes per centimeter. So if we assume a house with 4 bedrooms, floor area not exceeding 200 square meters, and fixture units not exceeding 20, then the design flow would be 2,000 liters a day. So the first thing we would calculate is our stone area for our stone and pipe distribution layer. So this would be calculated based on Q over 75, since the design flow is less than 3,000 liters a day. So 2,000 liters per day over 75, the minimum stone area would be 26.7 square meters. So in the sketch on the right hand side, you can see a stone area there, 7 meters by 4 meters or 28 square meters. The next component is the filter sand. So this is your specific filter sand that meets the gradation requirements of the code. And this is calculated based on QT over 850. So our Q is 2,000 liters a day. Our T time of the underlying soil is 25 over 850 gives us a minimum filter sand area of 59 square meters. So you can see in the sketch on the right hand side an area 8 meters by 8 meters, which provides 64 square meters, and that meets the minimum requirement. The third component is the total loading area. So in table 8741, the maximum loading rate for soils with a T time of 25 minutes per centimeter would be 8 liters per square meter per day. So our flow is 2,000 liters per day over 8 liters per square meter per day gives us a minimum total area of 250 square meters. So you can see in the sketch, we include the 15-meter mantle that extends from the stone layer, and we've given a total length of the bed of 22 meters by 12 meters, and that gives us the minimum area needed. Now, if we take that same example, and we have a site with an underlying soil that the T time is 40 minutes per centimeter instead of 25, we can rerun those calculations and see how the filter bed size does increase. So if we have the same house, 2,000 liters per day, and the underlying tea time of 40 minutes per centimeter, the stone area does not change. It will still be the same as before because it does not depend on the soil tea time. So you can see in this sketch, I have that same 4 meter by 7 meters area to provide the 28 square meters for the stone layer. The filter sand area is based on QT over 850. So now we have to use our Q of 2000 with a T time of 40 over 850. And our filter sand area is now going to be 95 square meters. So you can see in the sketch, I'm showing an area 10 meters by 10 meters, which gives 100 square meters, and that meets that requirement. Then we have to look at the total loading area. So for underlying soils with a T time of 40 minutes per centimeter, the maximum loading rate is now 6 liters per square meter per day. So that means the area of the bed now has to be at least 334 square meters as compared to the 264 square meters we calculated when the soils had a T time of 25 minutes per centimeter. So you can see in the sketch, I've shown the same overall length of 22 meters, but I've increased the width to 16 meters, which gives us 352 square meters, and that meets the minimum requirement of 334. So you can see how, based on the underlying soils, the leaching bed does get larger as the tea time goes up because we're trying to get that effluent to disperse and absorb into the underlying soil at a rate which it can accept. One of the things we hear as industry practitioners is that there's a lot of inconsistency in how filter beds are sized or constructed or permitted. So a number of years ago, we decided to prepare a best practice document that looks at filter beds and provides guidance on the best way, the proper way to design and install these systems. So we polled our membership and asked for them to provide us with what they see as the key issues for filter beds, and we put that together into this best practice document, which can be found on our UA website, www.ua.org. When we were putting together the best practice document, we polled our membership and generated a list of the most common issues and inconsistencies with the application of filter beds. And this is what we have: filter sand compliance with the specifications in the building code, even distribution of effluent over the surface of the filter, loading rates, proper application of the loading rates in table 8741 of the code, the 75% rule, interpretation and application of this rule, in-ground beds being constructed in unsuitable soils, so the bathtub effect, incorrect sizing of filter beds, life expectancy issues, and proper backfilling materials and practices. So these were the issues that were covered in the best practice document. I'm going to spend a little bit of time discussing some of the more key issues from this list in the next few slides. One of the key issues is ensuring that the filter bed is sized appropriately for the underlying soil. So if you recall, we discussed that the two functions of the filter bed are to provide treatment, but also to disperse the effluent into the underlying soil. And because we're concentrating that effluent into a smaller area of treatment, we still have to make sure that the overall bed size is adequate for the underlying soil properties. So the intent of the loading rate requirements is to reflect the underlying soil properties, to limit breakout, and to limit the possibility of an undersized system. So 8752 sentence 2 in the code states that the area described in 8742 sentence 1 shall be designed such that the loading rate does not exceed, for soil having a percolation time set out in column 1 of 8741, the maximum value set out opposite it in column 2 of table 8741. So this table provides us the range of tea times for the underlying soil and the corresponding maximum loading rate. So this is what we use to calculate the total area required for the filter bed. So the total loading area for the leaching bed is calculated based on the loading requirements in table 8741. And then we have to look at whether the native soil material can provide that requirement or whether imported material needs to be used. So if the native soil has a tea time greater than 15 minutes per centimeter, or if there's insufficient depth, 0.25 meters or less, for at least 15 meters beyond the outermost distribution pipe, then the filter bed is going to require additional imported sand fill material to provide the rest of that loading area. When we're looking at the total area, we have to consider the 75% rule. So this rule must be met between any of the mantle sand or loading area sand and the filter bed material. So if we're not going to use the same filter sand for the entire bed, if we're going to use a different sand fill, which perhaps in some areas this is going to be more cost effective, we have to look at the 75% rule to make sure that the difference between those two materials is not too great. We also have to look at the mantle extension, so meeting natural grade to avoid saturation of the mantle. The 75% rule is described in 8742 of the building code, and it applies to all fill-based leaching beds, so both trench beds and filter beds. And 8742 sentence 2 describes the 75% rule, which if we reword it a little more clearly, it's essentially saying that the tea time of any leaching bed fill material that's used in the portion of the bed containing the absorption trenches, or in this case, the filter media, shall not be less than 75% of the tea time of the soil or leaching bed fill that is used in the mantle. So what this does is it limits the percolation time to 15 minutes per centimeter or less for the mantle area. So in some sites you can use native soil material as your mantle area if you have sufficient depth and sufficient extent of this material to meet the requirements of 8742. But if the tea time of the native material exceeds 15, then imported material is going to be required for a filter bed to ensure that this 75% rule is met. So where the native soils on a site are a tea time of 15 minutes per centimeter or less, a filter bed can be installed in ground as long as you meet the vertical separation requirements in the code. So what happens here is that your native soils become the mantle, a natural mantle that meets that 75% rule, and if it extends at least 15 meters beyond the outermost distribution pipe and at a depth of at least 0.25 meters, it can become your natural mantle and meet those requirements. But it's important to remember that the filter bed, when the filter bed was studied originally by Chowdhury, it was an under-drained sand filter. So the filter bed must remain unsaturated, and it must remain aerobic, and it must freely drain the effluent. If a filter bed becomes saturated, it's going to become anaerobic, and proper treatment of the effluent is not going to be provided. So back to the original studies that were conducted by Chowdhury, those under-drained sand filters were freely draining and provided good aerobic conditions, and that's what enables the sand filter to provide proper removal of the pathogens and the BOD and the solids in the effluent. So it's important to make sure that when you're designing and constructing a filter bed, that it's going to remain unsaturated to have proper treatment. This is an excerpt from the OBC Part 8 course manual for on-site sewage systems 2012, which is based on the 2012 building code. And this just reinforces the last few slides we've been talking about, that the filter bed must be constructed as fully raised when the T time of the native soil exceeds 15 minutes per centimeter. So sometimes the interpretation of those requirements for the 75% rule and the mantle, sometimes those can be interpreted differently and they may not be 100% clear in the code, but this is the interpretation and the intent of these as described in the training manuals, that if the site has a T time exceeding 15 minutes per centimeter, you must raise the filter bed and use imported material for that mantle in order to meet the 75% rule. And it also keeps that filter bed unsaturated and properly treating the effluent. This illustration comes from the Part 8 course manual as well. And it just shows an in-ground filter bed, and it's based on a T time between 1 and 15 minutes per centimeter in the surrounding soil, and shows that you can install your filter bed in-ground in these conditions. This is a photo of an in-ground filter bed during installation. So on the left, you can see the prepared excavation. The base has been nicely scarified, and you can see that that native soil material is quite granular. It was a very nice sand and gravel material with a good percolation rate of approximately 10 minutes per centimeter. So that allows us to put the filter bed constructed in ground, and the native soil becomes our natural soil mantle for this bed. Let's take a look at an incorrect installation and what would happen if you installed an in-ground filter bed in soils with a T time greater than 15. In this case, I'm assuming the soils are quite a bit higher than 15. Let's say that this is a relatively low permeability environment, and as you excavate deeper, you're going to be into soils that have a lower permeability. Perhaps there's a lot of silt and clay in this material. So if you install the leaching bed in ground, the effluent may drain freely through the sand, but once it runs into this limiting layer at the base of the filter sand and the native soil, it's going to start to accumulate because it can't percolate downward. It's going to start to move laterally, but it's going to accumulate, and eventually you're going to create what we call a bathtub. And this is going to saturate your sand filter. And if you recall, a few slides ago, we discussed that the filter needs to remain unsaturated and aerobic in order to provide proper treatment. So we really don't want to be installing beds in ground unless we know that the surrounding soil has a T time less than 15, so that it can provide that free movement of the effluent into the soil and away from the filter itself. This photo shows an example of what happened when there was an installation in ground in a T time that was relatively high, and the bed became saturated relatively quickly and began to fail. And they actually installed a drain into a nearby ditch to relieve the hydraulic pressure on this bed. So this is not what we want. We don't want inadequately treated effluent migrating directly to surface water. We want to have the filter bed providing proper treatment and dispersing properly into the underlying soil. Here's another example photo of a filter bed that was installed in ground, and you can see, based on the amount of biomat and black staining on the stone and around the soil, that this bed is quite saturated. It's holding effluent, and as a result, it's become anaerobic. So it's no longer draining, and it's no longer providing proper treatment of the effluent. Now, if we take that same filter bed and those same underlying soils with a T time greater than 15, we want to install a raised filter bed. And this is going to allow us to have the base of that sand filter stay unsaturated and aerobic and provide good, freely draining treatment. And then when the effluent moves vertically through the sand, it's going to contact the shallow, more permeable soil layers, and it will be able to move laterally and disperse into the surrounding soils. Another topic that's discussed in our UA best practice document is proper backfilling practices. Proper backfilling is required for all leaching beds. We need to make sure that leaching beds are able to properly treat and disperse the effluent. So you want to backfill and grade the surface of the bed to make sure that there are no surface depressions. You want to make sure that the surface water drains away from the bed so as not to hydraulically overload it. And another important consideration is the depth and material of cover. So you want to cover the leaching bed with an appropriate depth of material that protects it but isn't too much cover to the point that it limits air movement through the soil, because we want to make sure that the bed stays aerobic. You also don't want to use a low permeability cover material. So if you have a thick layer of topsoil that has a lot of clay in it, you could potentially cap that leaching bed and prevent proper air movement into the sand filter. If you don't have good aerobic conditions, you're not going to get proper treatment in that sand filter. You also want to make sure that you have a breathable geotextile material placed over the entire stone area, which protects it from any finer particles from the topsoil washing into the stone and clogging it. And you want to make sure that you backfill with a good clean septic sand and topsoil on top of that, and make sure the grading on the side slopes is done in a way that prevents erosion, and the bed should always be seeded or sodded to stabilize against erosion. Another topic that we discuss in our best practice is ensuring that you're properly sizing the filter bed. So the minimum sand filter area is calculated based on the relationship QT over 850, where A is the contact area between the sand filter and the underlying soil. And you're calculating that based on your design flow Q and your T, which is the T time of the underlying soil to a maximum of 50. It's important to note that the T used in this formula is not the T time of the imported material or the filter sand. That is the leaching bed fill. The T time has to be the T time of the soil, which is your native underlying material. And this is very important to make sure that your filter bed is large enough to disperse the effluent over an area that the underlying soils can accept. Filter sand that's used in a filter bed has to comply with the specifications that are contained in the building code. And you'll recall when we discussed the original Chowdhury studies in the 1970s that they tested a range of materials. They tested fine sand right through to pea gravel, and they found that the coarse sand material was the best combination of freely draining but provided adequate treatment and pathogen removal. So that's why it's important to make sure that the filter sand complies with the specifications that are set out for that material. So it should be a medium to coarse sand, and it's usually quite granular with little to no fines, so little to no silt or clay sized particles. If the sand quality is poor, it's going to affect the filter bed performance, so it's very important. If the sand is too coarse, you're not going to get adequate treatment of the effluent. If it's too fine, there's a potential for that material to clog. So a properly graded sand and having the effluent evenly distributed throughout that sand filter is going to provide the proper treatment for the filter bed. The supplier of that material should be providing test results that demonstrate that the material meets the specifications in the code. So you need to have a grain size test and cross-reference that grain size test with the specs in the code to make sure that that material meets. You want to make sure that the test is representative of the material that's actually being delivered to the site. If there's any doubt, it's a good idea to take a sample of the material delivered to the site and have it tested to confirm that it's suitable. It's also important to consider limiting how much the material is handled or how long it is stockpiled, because that can affect the material properties if it gets handled too many times. So let's look at a couple of graphs that illustrate the specifications for filter sand. So this graph is the original filter sand specifications, and this comes from the old MOE Green Book in 1982, and it shows you two curves, two lines on this graph, and the filter sand should fall in between those two curves in order to meet the specifications. If we plot a similar curve based on the specifications in the Ontario Building Code, this is the limits for filter sand. So on the left, you can see that line corresponds to an effective size of 0.25 millimeters with a uniformity coefficient not less than 3.5. And the right side line corresponds to an effective size of 2.5 millimeters with a uniformity coefficient not greater than 1.5. And overall, the uniformity coefficient cannot be greater than 4.5. So that's what's contained in the building code. And a supplier of filter sand material should provide you with a graph that can be plotted against these two lines and needs to fall in between those two lines. In this slide, you can see a photo of 3 different materials, all of which have been considered filter sand by one person or another. So on the left, you can see a very visibly coarse stone material. In the center, a coarse-grained sand with some gravel, and on the right, a finer sand material. Let's take a look at these 3 samples a little more closely. So the one in the center is a visibly coarse-grained sand with some gravel, and if we plotted a grain size curve for this sample, it would fall nicely in between the 2 outer limits for the filter sand specs that are in the building code. If we look at the sample on the left, it's visibly much too coarse. There were some very, very large stone pieces in this sample. You can see there were pieces that exceeded 10 millimeters in size. And the paperwork that was provided for this material showed a material that met the filter sand specifications. It was on the coarse side of the spectrum, but still within the specifications. But the material that was delivered to the site did not match the paperwork. So it's very important to make sure that even if you have paperwork that demonstrates a sample meeting the filter sand specifications, that the material that's actually delivered to the site matches that paperwork and testing. Because this was a case where we needed to have a different material because this was just much too coarse, and the effluent is going to move too quickly through this material and not provide adequate treatment. So at the other side, on the right hand side, you can see a photo there of a much finer sand material. It's a nice sand, and this could be used for the mantle, but it wouldn't be adequate as a filter sand because it was just a little bit too fine and it could potentially clog. So it wouldn't meet the specifications for the filter sand, but the one in the middle, that's what typical filter sand will look like. Another topic in our best practice document is even distribution. This is critical. Even distribution of the effluent is really important for a filter bed, because remember, you're concentrating that treatment into a much smaller area, so you need to make sure that you utilize the entire filter sand volume. So you want to make sure that you distribute the effluent and spread it evenly over that whole surface so that it can percolate downward through the entire volume of filter sand, and this is critical for adequate treatment of the effluent, and it prevents preferential flow paths from developing. So the building code has in the appendix notes a recommended maximum spacing of 1.2 meters between the distribution piping in a filter bed. And again, this is so that you don't have the distribution pipes spread too far apart and you're not utilizing the whole filter surface. You want to make sure that you get good, even distribution, so that recommends a maximum spacing. The other thing the code does is it limits the design flow that can be used in conjunction with a filter bed and the maximum size of the filter bed to 50 square meters. And again, this just comes down to being able to make sure we get good distribution and as a result, proper treatment through the filter. So this photo just shows a filter bed under construction, and you can see that the stone layer has been split into two different cells, and this is because when we calculate the minimum stone area, it exceeds 50 square meters based on the design flow of the home. So we've split it into two cells in order to make sure that we can get good, even distribution and not exceed that 50 square meter maximum area.
Dieter, we seem to have lost sound.
On each of the filter surfaces.
Never mind, it's back.
There are a couple of other topics in the UA best practice document for filter beds, and I'll just quickly review those, but we won't spend a lot of time getting into detail. One of them is the life expectancy of a filter bed. So this can be reduced when an improper sand material is used. So if the sand is too fine, it's going to clog more quickly and it won't last as long. If the system was undersized, if it was heavily used or abused by the owner, if it's not properly maintained, if it's installed too deep into the ground and there's not proper aerobic conditions and unsaturated conditions, if the backfill is improper and it smothers the bed. So for example, if a clay material is used over top, you're not going to have good aerobic conditions, and this can inhibit the function of the bed and shorten its lifespan. Similarly, if you have uneven distribution of effluent over the filter surface, you're going to get preferential flow paths developing, and parts of your filter are going to be more heavily loaded than others, and they will, as a result, not last as long. Or if corners are cut during installation, obviously, shortening your depth of material or your extent of material is going to also shorten the lifespan of that sand filter. Thank you for joining us today to talk about filter beds.
Okay, that was the presentation that we had from Oboa. For any follow-up questions, please contact Mike through the email or your local municipality if you're not a building official. Otherwise, please reach out to colleagues, peers for information pertaining to on-site sewage systems and filter beds. So next up on our presentations for today, we have Corey McCambridge from APA, the Engineered Wood Association. And Corey, I'm just going to turn the floor over to yourself and hope that you can provide us a little bit of a self-introduction and information on your advanced framing presentation here today. So Corey, the floor is yours.
Excellent, thanks, Dieter. Just want to confirm you can hear me?
Yes, we can hear you, Corey, and I can see your slides as well.
Perfect. Okay, so let's begin. Thanks again for inviting me here to speak with you all today. As Dieter mentioned, my name is Corey McCambridge. I'm the Canadian representative for APA, the Engineered Wood Association. So who is APA? Well, it's a good question. We're a nonprofit trade association. We represent North American manufacturers of engineered wood products. And we've been doing so for 88 years. We're in our 88th year right now. Our primary functions: product certification and testing, applied research, as well as market support and development. And so I just want to share a couple of old archived photos here. You can see a photo illustrating the strength of the very first engineered wood product, plywood. So this was really innovative at the time. This is back in the 40s. And here again, you see another photo of, an archived photo, probably in the 40s, probably one of our first member mills. You can see the log being peeled into veneers. These veneers are going to be used to make plywood panels. So over the course of 87 years, the list of APA members has expanded, as you can see here. We now have approximately 177 member mills spread out across 23 states and 7 provinces. And we even have some member mills that are located in Brazil and Chile as well. And so the list of engineered wood products that our members produce is much different than it was 87 years ago. APA members produce a wide variety of engineered wood products, including plywood, as I mentioned, OSB, glue lam, CLT, wood eye joists, as well as structural composite lumber that includes LVL, LSL, OSL, and PSL. And so since the list of APA members has expanded along with the types of engineered wood products that they produce, we decided we need to expand our research facility. We just recently upgraded. We spent about $5 million to upgrade our research facility, our lab located in Tacoma, Washington. And we're really excited. I'm just going to give you a quick sneak preview. It's already built. It's in full operation right now. So I just want to kind of go through some of the things that we're going to be doing here and tests that we're going to be looking at this year. And one of them is looking at different types of beam layups, looking at different types of fasteners in certain locations to help get more use out of these products. We're really excited about being able to do full-scale diaphragm testing now. As you can see here, we've got our actuators, and we're going to be actually looking at cantilevered diaphragms. That's something that's new. I don't think it's ever been done before, so we're really excited about that this year. And one we've already started our research on is a high-strength shear wall. And so we're going to be looking at multiple details and construction methods. Where are we going to place these materials in order to get really high strength out of these engineered wood products when they're used as shear walls? And so we're really excited about that as well. There's already some promising news coming out of the initial preliminary studies and tests. So we're going to be very excited to share that information with the industry, hopefully later this year. So there's 4 key divisions at APA. The first, Quality Services Division, they provide the certification at the mills to ensure that the products produced at those mills conform to the product standards as well as APA policies. We also have a Technical Services Division. They operate out of our research center that we just toured. They serve as the engineering foundation of our market support and development programs. Next up, Field Services, that's my division. Full-time engineer wood specialists located across North America. I'm the Canadian rep. We're here to help out. We're here to offer advice as far as design, specification, installation of our member products. And obviously to conduct training sessions like we're doing here today. And then finally, our market communication division, they really combine all of the information gathered and learned by our other divisions and use it to create useful tools and publications for professionals in the industry. And so I just want to quickly walk through our website. We have numerous publications and tools. I just want to walk through it with you here before we get into our session today. If you're interested in looking at any of these tools and publications, have a look at our resource library. You can see that we've got different categories of publications. You can download CAD details. You can look at webinars that we have pre-recorded on there. Lots of publication categories, some that may be good for your work. Some of the technical topics, technical notes, some of the product standards, product reports as well. And so just want to touch on product reports really quickly. APA product reports help building officials and design professionals determine a product's conformance with codes and national, international, or industry recognized standards. And they're available to download from our website for free. We issue these reports to document the compliance of an engineered wood product that is manufactured under a quality program that's audited by APA. These APA product reports signify the product's compliance with the relevant provisions in the model building code, They're also assigned based on product classes, as shown here, the different series available. And really quickly, when you're going through and you're looking for product reports that are applicable for the Canadian market, make sure you get the one that's got the little C next to it. That makes, ensures that you're getting the right one for the Canadian market. One other quick section that I want to go through very quickly here is the design and build section of our website. We've kind of broken it down into building types, so you can get residential, commercial, as well as our design solutions tab. So basically, we have a lot of publications, like close to 700, I think. So we're just trying to filter them and make it easier for users who come on our website looking for specific information. So don't forget about the design and build tab. It might lead you to what you're looking for a little bit quicker. The design solutions one is really good because it kind of breaks it down into a specific topic. And of course, if you're navigating our website, you're getting frustrated, you can't find what you're wanting, we do have a help desk that's there to help. I encourage you to reach out to me first. I'm your rep. I'm happy to help. But then if I'm not available, we also have a help desk. And really quickly, before we get in, I get this question a lot. What are APA's accreditations? So the answer is APA is accredited by the following state, national, or international organizations. And as you can see, we've got the Standards Council of Canada on that list, so everybody can breathe a sigh of relief here. As I spill my water all over myself. Okay, now that we have a better understanding about APA, let's dive into our topic for today, and that's advanced framing. We're going to learn how to optimize our structure. We'll focus on options that balance structural integrity, energy efficiency, and cost effectiveness in engineered wood floor systems, along with above grade wall assemblies. So prior to joining APA, I spent 12 years designing engineered wood floor systems for homes built in prefabricated facilities. So during that time, I was able to analyze multiple products under many different conditions and configurations in order to determine the best performing and most cost-effective and labor-effective layouts. So I'm going to share some of the tips and tricks that I've wrote down over the decade of work that I did as a designer, and I'm going to share those with you today. We're going to start off with our floors, obviously. And the first thing you want to do as a designer is identify some of the variables that are going to impact the performance of that floor system. And I'm talking about things like your finished floor products. Is it going to be marble, ceramic tile? Is it going to be hardwood? They all have different weights associated with them. Same thing with kitchen islands. We know that these are becoming really popular. They're generally located in the middle of a span. Usually the kitchen, it's usually a big room, so it's a large span, and now we're putting this big, heavy island on top. These are things we need to identify and incorporate into our design. Same thing with soaker tubs. Again, they have the potential to add a lot of extra dead load, and depending on where they're located, it could negatively impact the performance of that floor system. We also want to look at the depth of our floor, what depth we want to use, and understand that with different depths of I-joists come different series. And I just want to highlight really quickly right now that a low series 11/7/8, like maybe and here we're looking at the PRI series, each I-joist manufacturer will have their own series name, like Truss Joists has a TJI, Nordic has an NI. Here we're looking at the performance rated I-joist. That's a family, that's its product standard. So the PRI, you can see for 11/7/8, a PRI 30 might actually be cheaper than a 9.5 PRI 60. So just understand that as you go up in series, it's going to be more expensive. We're also going to look at span conditions. I have a slide that will dig into this a little more detail on the next page, so I'm not going to stress on it right now. We'll also look at deflection criteria. And again, I have slides in the coming slides are going to dig into it a little bit more. Finished and unfinished ceilings are going to have a big impact on the performance of that floor. A floor with a finished ceiling is going to be stiffer, stronger, and it's going to vibrate less. as well as whether the subfloor is glued and nailed. So most of the time now you see that most builders are gluing and nailing the subfloor, and this definitely helps with composite action of the floor system and will greatly improve the performance. And then we're also going to look at our subfloor thicknesses, performance categories, so the thickness of that subfloor, as well as span ratings. And again, we'll dig in the coming slides here. So I promised to talk about span conditions, and I think as far as floor design goes, if there's one thing you take away from this particular part of the session today, it's this. Let's walk through our span conditions. So the first one is a simple span. It has two supports, simple, A, B, that's a simple span. The next up is a continuous span, and that is when it has three or more supports. The floor member, it has three or more supports. Then we have a cantilevered span condition, which is kind of a hybrid between the two. You've got two supports, but the beam or floor joist or floor framing member runs continuous across that second support. So you get a kind of a hybrid, and that's called a cantilevered span condition. So let's run through an example here. I just want to highlight the benefits of continuous spans versus simple spans. So if you look at the example on the top, I've run this in a design software. And we've got a PRI 60, a 9.5-inch PRI 60 joist. In the top, you can see I've got two joists. They're spanning 16'9" on one side and 16'9" on the other. So in the top example, we have two simple spanning joists. And you can see that when I run the design, I get a deflection of 0.412 inches. Now, in the bottom example, I'm going to take the exact same loading, exact same series joist. It's a PRI 60, it's 9.5. The only difference is it's one joist spanning continuous across that middle support instead of having two joists, one on either side. So we're going to go from a simple span to a continuous span. We're using the exact same joist, same loads, everything's the same. You can see the deflection now. Just by going continuous, I've been able to reduce the amount of deflection in that floor system. And I'm going to take this one step further here. In this example, same span, right? Now, I told you that lower series joists are going to be cheaper than higher series joists. So look at this. Just by going continuous, I can use a lower series joist and still have that floor system deflect less. So this is a great opportunity for designers and builders to build a better floor system that actually costs less. Okay, I also want to talk a little bit about deflection criteria. Most of us know that the building codes limit the live load deflection criteria to L/360 minimum. As a designer, I highly recommend increasing this to L/480. But what the heck am I talking about? L, what is L? L equals the joist span in inches. So let's run through a bit of an example here. Let's say I have an 18-foot span. If I convert it to inches, I get 216 inches. If I take 216 inches and divide it by 360, you can see that any joist that deflects 0.6 inches or less is going to pass the design. But to me, anything over ½ inch deflection is too much. And so we take the same number now, 216, and we divide it by 480 instead of 360. So we increase the deflection criteria, and that actually decreases the allowable deflection, making that floor stiffer. So this is why I highly recommend going to an L/480, because anything over ½ inch deflection, you're going to feel that in the floor. All right, let's talk a little bit about subfloor thicknesses and span ratings. APA members produce a variety of subfloor thicknesses. The first one I want to talk about is 19/32 or 5/8, and generally those come with a span rating of 20. So that means that no joists can exceed 20 inch on center under that panel. And I would never, as a general rule of thumb, and this is my personal opinion, I generally don't like to exceed or approach the maximum span rating. So I would never go 19.2 under this particular panel. I would always kick it back to 16 max, 16 on center max. under this panel. What about a 23/32 or 3/4 subfloor? You'll notice that the span rating is increased on these panels naturally to 24. And so in this particular case, my own personal opinion, I would not exceed 19.2 inches on center spacing of my joists under this particular panel, even though it is rated for 24. But again, I never like to really reach that maximum. Never like to test those boundaries. Finally, well, not finally, but another popular subfloor thickness that our members produce is 7/8 category. And you'll notice that some come with a span rating of 32, but some come with a span rating of 24. So I just want to highlight, it's really important here to, when you're specifying the subfloor thickness, also specify the span rating. Because if you're looking to go 24 on center with your joists and you get a 7/8 subfloor panel that's got a span rating of 24, you're testing the limits, right? So you want to go 24 on center, you want to make sure that 7/8 subfloor has a 32 span rating. All right, let's move back on to some of those design tips. We can utilize engineered wood products, long lengths for continuous spans. Engineered wood products are available in long lengths, up to 60 feet, depends on your local supplier. But I've seen many cases where 40 feet were readily available, you know, up to 45 feet. So utilize those long continuous spans. Look to add load-bearing walls or drop beams at room separations. Try to avoid flush beams. We'll get into that. When you're looking at drop beams and you're looking at continuous spans for I-joists, try to balance the span on either side as much as possible. You want to try to avoid situations where you have, say, 18-foot span on one side and then 2 foot on the other. That's when you get a lot of uplift conditions. And we'll show you an example in the coming slide where that may occur. Obviously, in order to take advantage of continuous spans, we want to try to avoid flush beams wherever possible. We know that, you know, this isn't always possible. This isn't always the case, that we can't always avoid them. And so when we do have flush beams, just remember, you're not going to be able to do a continuous span. And you're also going to be very limited with regards to, you know, HVAC and mechanicals, because up until recently, you were very limited with the allowable holes in LVL beams. You can see here, you were limited to the middle third of the span and middle third of the depth of the beam, and the maximum hole size would be 2-inch diameter. Very, very limiting. And I say up until recently because well, I guess it was about a year ago now, or just under a year, we released this technical note. It's available on our website, and it discusses large diameter holes in LVL beams. So using these formulas, engineers could potentially size a hole that's 2/3 the depth of the beam. So you could say let's say you have like an 11/7/8 beam LVL. You could potentially get a 7 to 7.5 inch diameter hole in that beam. But again, it depends on the span and loading conditions of that beam. You know, that beam may have worked as a 2-ply, you know, but now that you want to put that hole in it, it's got to be a 3 or a 4. So this isn't something that can be done on site. It's got to be done by an engineer. And these are the formulas that are going to be referenced in this guide for engineers to use when sizing holes larger than 2 inches in LVL beams. Okay, so for I-joists, the maximum allowable hole size is proportional to the shear force. So the shear force reaches its maximum near the supports. So if we draw a line from the top center of the web to the bottom of the web, just above the support, we will have drawn a line that represents the inverse of the shear force. The height of the line at any given point approximates the permitted hole size at that location. But just remember that all holes should be centered in that web. We want to see it centered. Okay, let's get back to some tips here. When we're looking at our floor systems, we look at offset loads. We try to eliminate those as much as possible. These are like loads coming down from girder trusses or from flush or drop beams. Follow those loads down. Where are they falling? Try to eliminate those offset loads, and I'll give you an example in the coming slides. We also want to identify plumbing and HVAC interferences. right? You could have a really efficient floor system layout, but it just doesn't jive with the HVAC. So these need to be incorporated in that in this process. Most of us are aware that mixing engineered wood products with dimension lumber products only leads to headaches and issues. This is because I-joist depths and engineered wood product depths are not the same as conventional lumber. You get a 2x10 that is 9 1/4, and you get a 9.5 inch I-joist. So they just don't jive. So don't use them together in flush conditions. And then avoid changing the joist direction as much as possible. When you change the joist direction, I've seen it many times, it can create a hump in that floor system. What else does it do? It may actually impede, HVAC and plumbing and electrical runs. So trying to keep everything running, the joists in the same direction, is very advantageous. Also, think about your subfloor installation. When you install the subfloor, it's got to be installed with the strength axis perpendicular to supporting members. And when you change the direction of your supporting members, you got to change the direction in which that subfloor is installed. That leads to a lot of cutoff material waste and slows down, things on the progress on the construction site. So keep it all in the same direction as much as possible. So those are some, really quickly, some design tips and tricks. When you do this and apply these early in the process, like the preliminary stages is the best time. As I said, this could really change the design. So you don't want to be doing this after you apply for permit. So let's go through some examples right now, really quickly, before we get into walls. And this is the first one I want to pull up here. And you'll notice right away under the great room, we've got a 9.5 inch joist trying to span 17-foot simple span. When I look at a span table for simple span joists, I can see that I can't even get a 9.5 inch joist to go 17 feet. So I'm instantly going up to an 11/7/8, and I've circled some options there that will achieve that span. But I don't like simple spans. I like continuous spans. So if I were to look at this and maybe apply some of those value engineering tips and tricks we learned, what do we get? Okay, green represents a drop beam, blue represents a flush beam, red with arrows represents the proposed joist direction, red circles point loads that need to be attended to or at least looked at. Okay, so you can see now I'm proposing that the joists run left to right, continuous. And I also want everybody to look at those 2 red circles by the stairs on the image on the right. Follow those point loads down to the basement. Where do they land? Right in the middle of the steel beam. So we want to stack our loads because we want to avoid having point loads in the mid-span of a beam. Those point loads are going to make me upsize that beam. So if I were to simply just, change where those posts and pads are in the basement and align them with above, I eliminate those offset loads. And now I can probably use a wood beam in the basement instead of steel. So you can see now how aligning your loads and taking this all into consideration can really greatly impact the sizing of the members that you're going to need. And by going continuous span, you can see now we have many options for the 11/7/8, and we actually now even have a 9.5 inch option. So by going continuous, we're able to keep this at a 9.5 inch floor system. Let's have a quick look at this model. This example is a bungalow. You can see first off, you see joists running left to right, front to back, so they're changing their direction. It's going to be hard for HVAC. They're going to have to change the direction of the subfloor installation. I also see these joists here, simple spanning 15 feet. Okay, look at my span tables. All right, looks like I can get a 9.5 to work. It's got to be at 12 on center though. But what if we again look at this, apply our value engineering tips and tricks? What do we got? So here we go. Green line is dropped beam, blue is flush, red line with arrows is proposed joist direction. You can see I'm proposing to go continuous, fully left to right. But that means that under the master bedroom there, we got a span of just over 17'6". All right. So in order to achieve that, I need to go 11/7/8, but I've got some options here. And, I can go 60 on center. I can even get up to 19.2 on center with a PRI 70. So I've got some good options here. Some of you may be saying, yeah, but originally you were doing this floor at a 2x10s. Now you're going 11/7/8. That's going to change the stairs. That's going to add another row of brick to the outside. This is true. However, we were also able to eliminate 3 posts, 3 pads, and 55 lineal feet of steel. So, you got to do that comparison now. And suddenly the 11/7/8 floor system doesn't seem so bad after all. Plus, it's going to be a really good performing floor. All right, and then just to quickly here, I've actually done some designs, so I just want to show you all the potential. Have a look at this second floor framing system that was value engineered, and just look at the total number of joists on the bottom. Went from 91 to 32. We eliminated all the cross bridging, and we reduced the lineal foot of steel in this floor. So it's going to be a lot easier to build too. So your labor is going to be cheaper too. Less interferences. Again, here's the ground floor. Again, look at the total number of eye joists. We've eliminated all that cross bridging and strapping. All that cross bridging and strapping are potential squeaks. So we've just eliminated a lot of potential squeaks in this floor, and we've, pretty much cut down the lineal foot of steel almost in half. So really advantageous to look at value engineering of floor systems. So I'm going to keep moving along here. If anybody has questions related to floor systems, we may have some time at the end of the session, but I packed a lot of info in today. I'll put my contact info up at the end and you can reach out to me. I'm happy to work with any builders that want to review some of your models. I charge nothing for my services. So take advantage of it if you wish. Let's move on to walls. We can do this value engineering in our floors, but what about in our walls? Yes, we can absolutely do this. We don't call it value engineering. We pretty much call it advanced framing. So let's have a look at some advanced framing and some of the benefits that come with it. And so here's the key components of advanced framing. This is all of them, single or right-sized headers, energy raised heel or energy heel trusses. Looking at our corners in Canada, we need 2 studs for advanced framing. Looking at inline or stacked framing as well, when you have a single top plate. Looking at where your girder trusses are sitting, so stacking your loads, making sure you follow those point loads. 2x6 studs spaced up to 24 inches on center. Efficient use of framing around openings, right? And then sheathing our walls with OSB or plywood to kind of tie everything together. So we're going to look at some of these details today. We're not going to go through all of them. I'm only going to focus on the ones that are required by building code. APA has a great publication. It's a construction guide. As you can see here, it's 24 pages. It describes most advanced framing techniques in detail. These details are not clearly illustrated in the building code. So this poses a challenge sometimes to designers that are attempting to incorporate them into their projects. So we hope that this, this guide here will help to answer some of those questions and provide details. Okay, so let's focus on some of those details. When we look at the 2 walls, like maybe conventionally framed with an advanced framed wall, we can really see the difference here. Anything in yellow is being removed. That means we can have more room for insulation. That's going to boost the effective value of our wall assembly. So let's look at our corners. Here's the traditional ways that we use to frame our corners. These are not advanced framed corners. This is 2 studs with a drywall clip here will hold that piece of gypsum in place. This will allow full depth insulation to kind of get right into that corner and provide better thermal values in these areas. What if you don't want to use a drywall clip? Well, you could use ladder blocking, as you can see here in this detail. And this is a great advanced framing detail because it utilizes cutoff material that you've already paid for. You've paid for this material. It's sitting on the site now. It's cut off. Now you got to pay for someone to come and pick it up and throw it in a bin, and then pay for someone to grab that bin and take it to the dump. You could use a lot of this material in areas like this, in corners for ladder blocking, as well as ladder junction where interior walls butt up against exterior walls. You see the 2x ladder blocking there will allow full depth insulation at this junction, slightly compressed at the block. So it's going to help improve the thermal performance of that wall system. I mentioned it before, and that's right sizing our headers. This is a big one. I mean, I go on sites and I see all the time, I see 3-ply 2x10s, even though it's like only supporting a gable truss, no point load. So right size your headers. This will allow for insulation to be put into that cavity. It's going to help make that wall, increase the thermal resistance of that wall. Or why not use my favorite detail, and that is to actually just push that header right up into the floor system if you can do that. Again, this will allow full depth insulation around that opening. You could potentially use a double rim board, depending on the amount of load, but it is limited to a 4-foot maximum span. So if you have anything over that, or if your load doesn't allow that, you could just incorporate an LSL or LVL up against the rim board and just hang the joists off it. So I mentioned it, just paying attention to your point loads. If you have a girder truss that's sitting on a header, well, now that header's got to be sized appropriately. So I mean, maybe if you can change the location of that girder truss slightly, or maybe change the location of that window, or a combination of the two, you can avoid that direct contact and be able to size a smaller header, which will allow for more insulation in that wall. Again, this is all the concept of advanced framing, is trying to get more insulation into that wall. So here's a detail that I wanted to mention because it is not required. Single top plates is not an advanced framing requirement in Canada. And I'm kind of glad it's not, because it's very limiting. All of your framing members must line up. Your roof trusses must line up with your wall studs, which must line up with your floor trusses. And we all know that there's hardly any situations where you can have everything line up. I mean, what if I want to go 24 with my trusses, 24 on center? Then I have to go 24 with my wall studs. And then I have to go 24 on center with my floor trusses or joists. And I can't always do that. So stick with a double top plate. That's what I recommend. Now you have no maximum offset. Your roof trusses could be at 24 on center, your wall studs could be at 19.2, and your floor joists could be at 16. Double top plates is highly recommended. Okay, so we looked at some of those details. There aren't really that many details, but they do have a big impact when you start looking at walls with and without. And that's what we're comparing here. There's a couple of walls, that one that does not have advanced framing and one does. And you can see how it boosts the effective R value of that wall by applying advanced framing. And again, here's another assembly that you can see. This one had a little bit of foam insulation on the outside, a continuous insulation. And you can see just applying advanced framing boosts the effective R value of that assembly. So why am I stressing effective R values so much? Well, when you look at SB 12 in the building code, the different compliance packages, you have the option of meeting a nominal requirement or a minimum effective R value. Aha, you see where I'm going with this now. So let's have a look at, package A1, for example. Here's your nominal requirement, or you can meet an effective R value target of 1703. So now let's look at some advanced frame walls that can meet, let's look at some effective R values. So for the first one set of examples here, no advanced framing. All I'm doing is changing the on-center spacing of my studs. So I'm going 24 and 19.2, and you can see, how it boosts the effective R value of that assembly. Let's say I go full advanced framing and I change the on-center spacing of my studs. Now you can see the full potential. What nominally required an R22 bat, now I can get away with an R19. So I'm using less studs, my labor is cheaper, the wall's gonna feel better, and I'm using a lower grade of insulation. This is savings all around and better performance. Here's packages A2 and A5. Just kind of go through some examples here with you on share. Here's your nominal requirement, R19 bat plus 1 inch of continuous insulation, or here's your effective R value target. Again, don't want to do advanced framing. I just want to change the on-center spacing of my studs. Here's some options. And here I do want to do advanced framing, and I'm willing to change the on-center spacing of my studs. And you can see now that I don't even need that continuous insulation at all. I can get away with a 2x6s at 24 on center with R24. Pass that brick though. Last one we'll look at really quickly. I really like this one. It's a good example. Package A3. Here's your nominal requirement. It's a 2x4 wall, this one for the nominal. R14 plus 1.5 inches of continuous, or an effective R value of 18.62. Again, just want to change the on-center spacing of my studs. Here's an option. I can actually just use a 2x6 stud with an R24 and eliminate that 1.5 inches altogether. And then you have some full-blown advanced framing options as well. And you can see here, I can get a 2x6 wall at 24 on center with R22 bat to work. Let's move on. A lot of builders are looking at Energy Star programs, pretty popular. And again, here too, we can meet an effective R value target. And there are advanced framing options for even the Energy Star Zone 1 packages. So again, just keep this in mind. A lot more options when you look at advanced framing. And I wanted to know, what's the maximum effective R value that I can get out of a 2x6 wall, as well as a 2x8 wall, cavity only? I don't want to use any exterior continuous insulation on this. So here we go. We can get a 19.48 effective R value out of a 2x6 wall. That's the max without continuous insulation. And then with a 2x8 wall, here's the max, 23. So pretty high without even having to put any continuous insulation on that cavity. We'll talk about some of the advantages that come with that. I also want to touch base a little bit on programs like EnerGuide. They require a performance-based design approach. But here too, advanced framing details can be used in order to increase the trade-off options for designers and builders. So, these advanced framing will offer a lot of options with the prescriptive or with the prescriptive path as well as the performance. And I just want to highlight table 936.241A out of the National Building Code, because I always am asked, well, I need to know the framing factor for advanced frame walls. Well, here they are. And note that I can have an advanced frame wall with studs spaced at 16 inches on center, 19.2, or 24. So the stud spacing is separate from advanced framing, okay? I can have an advanced frame wall with studs at 16 on center. They don't need to be at 24 on center in order to comply with advanced framing. What you do need to comply with advanced framing are the following details, as defined underneath in the footnotes of that table we just looked at. Insulated or flush headers, corners with 2 studs, ladder blocking at T intersections. It says no cripple or jack studs, but I just say efficient use of framing around openings. We're going to dig into this a little bit internally. And then double top plates, so you don't need to have a single top plate. So those are it. Those are the advanced framing details that are required by the National Building Code. And any builders that are like, okay, well, maybe I want to start exploring some advanced frame walls. Are there any tools out there that will help me do this? Yes. The Canadian Wood Council has an excellent tool. It's called the Effective R Value Calculator. It's available for free on their website. Got over 10,000 assemblies in it. You choose the wall assembly components. It spits out a report, tells you what's the effective R value without advanced framing and with advanced framing. So it's a really great tool. It also tells you, it gives you a little report on each wall. For example, a 2x6 wall at 19.2 on center with R22 bat insulation, 7/16 OSB and vinyl. It'll say look at the color coordination. It'll say, okay, this wall, if you were to build it in any location here, like Vancouver, and all these locations across Canada, this wall performs well. But when you start adding continuous insulation to the exterior of the assembly, you'll note you start to see different colors. They're yellow now. They're not green anymore. You're getting a conditional pass. It's a warning. You're also seeing a red in Edmonton because we have not met the inboard-outboard ratio. In order to comply with that, we need to increase the exterior insulation thickness to 1.5 inches. Now you can see we eliminated the red, but we still have those yellow warnings. Now, what is it saying? Let's get into that. But first, if you're those of you are wondering the inboard-outboard ratio compliance, table 92552 is what you need to look at. Okay. Okay, so we all know that moisture and water management is one of the best ways to prevent mold growth and decay, which can lead to structural failure. So this image highlights what we refer to as the 4 Ds in wall design. Deflection, we get that from our overhangs and our roofs. Drainage, that's our cladding materials and the drainage layer. Drying, we want the assembly to dry if it does get wet, very important. And durable, we want to select durable material. There's the 4 Ds. So one very important factor to consider when selecting wall assemblies, and I can't stress this enough, is the drying potential of that wall. When leaks happen, and they likely will, how will the assembly dry? If bulk water is able to penetrate the assembly through improper window or door flashing details or improperly sealed penetrations, where will it go? Wall assemblies with low permeate materials on the inside, like poly/vapor barrier, and low permeate materials on the outside, they need special attention when it comes to window and door flashing details to prevent any bulk water intrusion from entering the assembly. One unique feature of wood structural panels, it's plywood or OSB, is that when the relative humidity rises, so too does the permeability of those materials, allowing any moisture within the cavity to dry to the exterior. But this is only true when there are no low permeability materials blocking that process. So this graph here illustrates how the permeability of OSB and plywood increases as the relative humidity increases. So you can see as the right, it's allowing trapped moisture in the assembly to escape to the outside as the relative humidity increases, only when it is not blocked. Okay. So far, we've learned how advanced framing techniques and details give us more options when it comes to energy code requirements. But one of the most common questions I receive from builders entertaining these ideas and details is, if I put my studs at 19.2 or 24 on center, what am I going to use to fasten my siding and trim? Most siding manufacturers require 16-inch on-center fastener spacing. And if the wall studs are spaced at 19.2 or 24 on center, you know where I'm going with this, right? Where are you going to fasten to? Well, this is where OSB and plywood sheathing come in. Continuous plywood or OSB wall sheathing is a secure, code-compliant nail base that provides an easy and effective solution for attaching all claddings. Let's review some of the advantages that plywood or OSB wood structural panels offer when used as a nail base. Well, they eliminate the need for cladding installers to hit studs. They allow for shorter use of fasteners and require that they fully penetrate the OSB or plywood by 1/4 inch. They ensure that cladding materials stay in place during high wind events, and they eliminate the need for additional blocking to support ventilation when siding or ventilation and siding when ends don't fall on studs. So without OSB or plywood to act as a nail base, the siding, along with any mechanical or electrical services, as well as wide exterior trim, will need to be fastened directly to the studs, which may limit them to a maximum 16 inches on center spacing, which, as we've learned, is not very good for advanced framing. Or to additional blocking installed within the wall framing as shown here. And again, this isn't always good, right? You want to increase the insulation thermal values of your wall. Adding more wood is probably not. when it comes to fastening recommendations when using USB plywood as a nail base for your siding and trim APA, as you covered, our nail-based sheathing or siding and trim attachment construction guide provides an easy method for determining the type and spacing of siding fasteners to satisfy building code requirements when using wood structural panel sheathing as a nail base for your cladding materials that have weights up to 3 PSF. This includes wood lap and panel siding, vinyl siding, fiber cement, wood shingles and shakes, synthetic stucco, and other popular cladding materials. So depending on the fastener type and the performance category of the wall sheathing, you'll find the recommended fastener substitution schedule. Just want to note that when using ring shank nails or wood screws, the fastener substitution schedule is 1-to-1 versus smooth or screw shank nails, which may require the use of additional fasteners. Okay, so it's really important the type of fastener that's being used if you're trying to utilize OSB or plywood as a nail base. And this benefit was put to the test by the Insurance Institute for Business and Home Safety, and the results are clear. Siding attached directly to continuously sheathed plywood or OSB walls is able to withstand the same wind and weather conditions as siding directly attached to frame. In fact, siding need not be attached to any framing members at all, so long as the fasteners fully penetrate the sheathing by a minimum of 1/4 inch, and the correct fastening schedule is followed. This is also true even when siding is attached to plywood or OSB through a layer of non-structural continuous insulation up to 2 inches in thickness. So as you can see, even after the roof system completely failed due to a high wind force, the siding remained intact. And this is, like I said, it's true even through a layer of continuous insulation up to 2 inches. Or you can just nail it directly to the OSB or plywood as shown here. Now, if the weight of the cladding materials exceeds 3 PSF, we have a technical topic which discusses fastening requirements for cladding materials with weights up to 11 PSF. However, this only applies when cladding materials are attached directly to the wood structural panel wall sheet. You can't go through a layer of foam. Okay, so we can use advanced framing details to help reduce lumber, labor, and installation costs. And we can use plywood or OSB to act as a nail base for our cladding attachment when studs are spaced greater than 16 inches on center. But are there any other advantages or benefits that come with OSB or plywood wall sheathing? Can anyone think of any? Some people in Barrie may, after last year's storm. They help to increase the resiliency of our structures by eliminating the risks associated with insufficient bracing. And you're going to get a kick out of some of these images that I'm about to share. What do we need bracing for? Well, during a high wind event, lateral forces push on one side of a structure, they pull on the other side, while at the same time, uplift forces attempt to pull the roof away from the structure. So we need we need to design our buildings with walls that are strong enough to resist these types of forces. This graph illustrates the racking strength of 3 wood-framed wall assemblies. One is braced using diagonal 2x4 lead-in bracing. Another is partially sheathed with wood structural panel wall sheathing. And the final wall is fully sheathed, and it includes window openings. It's important to note that in order for the diagonal lead-in bracing to resist racking forces, it must be installed at a 45 to 60 degree angle. As you can see, the fully sheathed wall with openings was able to provide up to 88% more racking resistance when compared to the partially sheathed wall with no openings. So fully sheathing our walls dramatically increases their ability to resist racking forces. Now, some of you are might be saying, well, I don't see these diagonal 2x4s. I see diagonal metal lead-in bracing. Well, we don't have any test results for metal diagonal bracing, but we would assume that they're going to be less than the 2x4 diagonal. That's all I can say. Well, this might be why temporary wood bracing is being installed on job sites in addition to metal diagonal bracing in order to keep things square during construction. But what happens when HVAC, plumbing, electrical trades come in to do their work? They want to remove all that temporary bracing because they can't get around, right? They need it all out of there so they can actually do their job. When they remove it, this is when the homes are most susceptible to failure because they don't have interior gypsum and they don't have any structural sheathing on the exterior. The way that we build our homes today is much different than they used to be. Our homes now have more window and door openings, and they tend to be larger in size, which leaves some walls with little to no room for the proper installation of diagonal bracing or interior gypsum wall sheathing. I mean, how much interior gypsum wall sheathing are you going to install on this wall? Not a lot, right? So that really limits the resistance capacity for this particular wall assembly. All of the failures observed in Southern Ontario over the past 4 or 5 years were the result of insufficient lateral bracing due to situations similar to the one that's highlighted here in this photo. So now I just want to quickly walk through, as we end our presentation here, a few examples of some homes in and around the GTA over the past 5 years that have failed due to this situation where there was a moderately high wind event. I mean, I don't know if you consider 70 to 90 kilometers an hour a high wind event. It doesn't even make the Fujita scale. It's not even an EF0. But we're getting failures. We're seeing a lot of failures, actually. And we're seeing consistency in these failures, right? Here's another example of some homes up in Brampton. No interior gypsum had been installed yet, and only foam and plastic insulation was installed on the outside. I don't know if there was any diagonal bracing or not. I can't confirm it on these ones. But you can see what's happening, right? And obviously, right? It's a non-structural sheathing. It's not able to resist these forces, and these homes are collapsing. This is happening in Niagara Falls too. I can keep going. Just pay attention to the wind speeds. They're really not that high. It's pretty alarming. Now, we'll also see in this particular event here, I want to show you this next one actually caught my attention. Usually you'd see up until now failures where it's kind of like dominoes. One house that's more exposed, gets pushed over and it causes the others to topple. But in this case, it was a different situation. You can see here they didn't fall like dominoes. Actually, the roofs fell perfectly almost in line with the foundation perimeter. This tells me that the ground floor walls failed instantaneously, very quickly. And kind of a scary thought for any trades or inspectors that are inside the home when this happened. It happened very quickly. So just be careful out there nowadays. If anyone's interested, we have an excellent publication which discusses above code methods that improve the performance of homes during high wind events. I also have a really good 1-hour presentation on this topic. I actually have a couple 1-hour sessions on this. Happy to dive into those with anyone that's interested in the future. Just reach out, let me know. Yeah, I'm just wrapping up here. So continuous wood structural panel sheathing lends structural integrity to the complete building system and boasts not only strength, but sustainability. Continuously sheathed wood walls simplify siding attachment, provide uplift resistance and lateral support for raised heel trusses, and result in a strong, resilient structure using a renewable, sustainable, and readily available resource. All right. So once again, I just want to say thank you for taking the time to listen to me today. We do have a survey. If anyone's interested in scanning that code, we appreciate it. It helps me improve for future sessions. And my contact information is here as well. So any questions or any individuals that want to have a look at some of your floors, or maybe you want to tour some of your models on site, I'm happy to do that with you. I work with framers. I do a lot of training and consultations, and my services are free. Everything from APA is free. So thank you again. I'll pass the mic on back to Doug. Thank you.
So Corey, we've got a question here from Jordan. When possible, could you go back to the information about the effective R value in relation to the advanced wood framing? The CWC site does not seem to match the details shown in the slides. I'd like to have clarification on the walls noted in slides for cost savings.
Aha, okay, let me see here. I'm gonna go back a bit here. Try to find it. Okay. So essentially you log into this, the effective R calculator on Google. If you Google that, you log in, you enter the effective R value calculator website, and it's not going to show up like this right away. This is an example of a report. So when you log in, you're going to have to go through and choose the components that you want. And then it'll give you a list of results that match those components. And then you can start diving into some of these individual reports of those walls. And if you're having some issues with this and you want to walk through it quickly, shoot me an email and I would be happy to kind of log in with you and we can walk through it together through Teams or something. Happy to do that. I'll try to get to the last page here again so you all have my contact information. Whoops, I went a little too far. Okay. Yeah, so have a look. I mean, there's over 10,000 assemblies in the database. So when you log in to the effective R calculator, you'll have to kind of go through and choose the assembly components you desire. And then you'll get a list of wall assemblies that match those components. And then you can kind of filter through that. But I'm happy to walk through with you if you need. Any other questions?
Thanks, Corey. I'm not seeing anything else here.
Yeah, thank you, Corey, for your presentation here today with that information. That was very informative and some very good benefits there when trying to incorporate advanced framing into standard in today's construction world and practices. So especially with trying to reduce cost, obviously everyone's aware of the price of materials, and you know, anytime that we can try and save whether it's a piece of 2x4 or 2x6 in a house, that's a savings back to the builder while still remaining code compliant. So again, appreciate your presentation here today. And for those in attendance, please follow up with Corey on questions on his presentation. In closing today's Builders Forum event, I would just like to thank everybody, our guest speakers that gave the technical presentations today, and for those that took their time out of their busy schedule to sit in and partake and take in the 4 technical sessions that we provided. So thank you again for everybody that participated, and we look forward to seeing you at future events, and whether that's hopefully in person and incorporating hybrids, then we can outreach further into the province as we continue to deliver this event. So thank you very much, and have a good evening.